Yeah, we're live now. Hey, I had that great music and I was vibing here, waiting for this stream, to see Sia, waiting to see lots of people on the backstage. And I have my coffee today. I have a sunny day and have a nice mood. And I want to actually say that RIA Global Summit 2024 by Geekle is live now. And here we are. Hey, Sia, how are you?
Hey Ed, I'm good. I'm actually excited. It's my second time doing the event for React community. So majority of the speakers today are good friends of ours. And yeah, I'm just super happy to see everyone and to start this event.
Our beautiful event manager, Sia, packed up all this event together and prepared for us. And I'm so happy that we are already here. The React community used to be largest community in our ecosystem. Now I believe architects community even bigger. But still, I love React people because you are guys so React. Sorry for the wordplay. This is the day, and let me tell you what to expect from this conference today. We have 2,200 registrations plus, I don't know, plus maybe 10,000 or something. 14 speakers, 5 on junior tracks for today, and 9 for senior track for tomorrow. We expected more, two speakers more for today, but some family matters and health matters, two of them just couldn't attend. So probably we'll have 5 only for today, and today we'll have 2 blogs and 2 Q&A sessions. Of course, we'll be talking about AI a lot, and I encourage you to actually share what's your experience, what your thoughts on that part. Of course, we'll be talking about new React features, new React build and stuff. And tomorrow, 3 blogs, real deep stuff, 3 Q&A sessions. That's how it will actually work. And yes, yeah. First of all, just a second. First of all, as always, our tradition. Yeah, you know the tradition, and you already sending us this. Um, your cities, please do share where I'm from, where you're based now, how are you, what's your expectations and stuff. I'm in Nice in France, and also please do share your LinkedIn or any other socials here in chat, because we're here to network, to follow each other, to be the real community. And it's really encouraging for us when you guys actually showing where you're from, where you're based, so we could sense you and feel like we do our job not for those monitors we see or for each other with Sia, but also for the community. So I'm in Nice, and I'm sending this in chat, so please do share. Okay, Sia, sorry. I will want to hear more about this event. Please do.
So, chat is not only for sharing your city or LinkedIn. I would like to remind you that you have an opportunity to ask the questions from the speakers. They are present live with us during the Q&A sessions. So please listen attentively and type your questions in the chat during the presentations. And also, you have an opportunity to ask them questions you haven't had a chance to ask someone before. So if you have a particular question for a particular expert, please type it also in the chat and I will raise them during the Q&A sessions. And kind reminders that you can buy a full access ticket to watch all the speakers' performances tomorrow. And we prepared a promo code, which is React Live, for 20% discount. And those who bought a full access ticket have some advantages. They get a certificate by mail after the live stream, and also they have access to individual recordings of speakers' presentations, and they are available for them to rewatch later. So yeah, use the promo code and jump into for tomorrow.
Yep, absolutely. Thank you very much, Sia. And we see lots of folks writing in chat. So, California, oh, people, it's a night there right now, I believe. how can you survive that? And I appreciate it very much. Bonn, Germany. Yes, it started. Okay. Hello from Tunisia. Hello from Cameroon. Nice, it was me. Portugal, Indonesia, Cameroon again, and France. Okay. Hello from France. And London, Indonesia, Spain again, and Nigeria and India. Anyone from India? Yes, probably we have some folks from India more, and please do let us know where from. And we are moving to actually teasers what exactly we will be hearing at this conference. Today, of course, hybrid rendering. Yes, this is the thing. Last days, server-side rendering and React server components and server actions. We'll hear also React app and Wing backend, of course, and just that's something interesting too. Building scalable UI with component-driven micro frontends. All micro frontends are still the buzzword and still trendy, of course. And for tomorrow, we'll have linters and formatters for React, uh, like gain performance, runtime, and to build time. Well, that's probably something real deep architectural stuff and usefulness and use weak references. Okay. And about performance once more, about mobile apps and React Freedom and seamless backend interaction. Yeah, as I mentioned, server-side stuff is booming. New era has come, and so must your database observability. Again, something real nice for architectural from architectural perspective. Harnessing AI for proactive data security and enterprise. AI, yeah, of course. And the Sound of Chicago. Sound of Chicago is should be a really interesting talk. I'm really waiting for that, and because it's really intriguing with its name and also the content you can read from abstract. Still leveraging component composition for vector architecture. So as you can see, more structural and engineering stuff for tomorrow. That's what we are expecting from topics and content perspective from this event. Okay, see ya. What's next?
Yeah, I'm getting ready for the next week as we are hosting Angular Global Summit, which will happen on June 4th. It's a free part, and paid part senior track is scheduled for June 25th. Really great program, 2 days of content, 9 speakers for junior track, 10 speakers for senior track. It will be a big, great event, which will bring some nice topics, really fresh in the industry. There will be a lot of live speakers present, also opportunity to ask the questions. So do not miss it out.
Yep. Yes. And more exciting from chat. Yeah, anyone from Angola? Well, probably yes. I see with Nepal and Bahrain and Morocco. I can't see anything screen loading. Well, guys, if someone has same issue, please do let us know. But as I feel from the chat, everything goes smoothly. Probably something wrong with the browser or internet connection. Please do check. And also, Valve Door in Germany, but originally from Lviv, Slava Ukraini, and India, Brazil, Congo, Slava, right? Congo and Hey Bro. Okay, Hey Bro. And yeah, I'll have to attend the meeting shortly. Will this be recorded? Yes, Pedro, it will be recorded. You can access it probably on a full access ticket, but still it's possible. Cameroon front-end developer and even LinkedIn link. Yeah, people. Thank you very much for being that active. More and more people come, and we just stretching this starting ceremony a little bit to let more people in before the first topic. They are actually the friends of mine, Refactor AI. They are trying to actually figure out how to harness AI power to serve developers to make our code better uh, in some way, probably, or faster, or just take from our shoulders some routine. And yes, yeah, what should we mention more? Probably about the hackathon, guys. Yeah, you never heard about that. And you probably the first audience who knows about that. I never sent even email about that, but we are going to build all together. I mean, all the community to build Geekle AI platform. It's something new. Our idea will be actually to create the first part is the engine where we could search for any software development solutions and compare in one table. Thanks to AI, it's possible. It was not possible before because lots of unstructured data. And once you need something, you go GitHub, GitLab, any other platforms, and you do lots of I search, trying to figure out will this solution work for you or not, and creating our custom spreadsheets, tables with comparison parameters and criteria and stuff. So no more. Geekle will take care about that, and this hackathon is to be actually the event where we'll will come all together and build that AI module. Oh yeah, we're working on that right now. AI module and comparison module, and also architecture module, and also we have lots of AI integration wizards. Yeah, so we have lots of ideas what to build to help actually developers build software because yes, generative AI is a nice direction, and those code completion and code generators are real nice at some point for some pieces of our work. But engineering stuff, we actually in Geekle um, believe that engineering stuff is the part that needs to be improved first, and AI can be actually used for that. Sorry for that long story, but I'm so excited about the hackathon. It will be the first one in the Geekle history, and I really, even nervous about that. So later on, follow our socials and follow updates via email. You will be able to join the hackathon and maybe win some prizes. Why not? Or maybe one of the last information about the hackathon is the the probably the most important prize we'll be offering there is the opportunity to join the founding team of Geekle. So probably it could be something worth to fight for. Anyway, no more information about anything. I don't know. Just let's get it started, right? Sia, please do introduce our friends from Refactor AI and whatever they actually offer, or maybe I will. No, it's okay. Yeah, I'll go and connect all of you in my LinkedIn who shared your links. Thank you very much for coming. Thank you for watching. Thank you for believing and contributing in this community, to every speaker who joined for this beautiful conference. And to you, of course, Sia, the stage is yours.
Thank you for the introduction, Ed. So let's start. Yeah, I would like to invite to the stage our first speaker, who is Vadim Smirnov, a good friend of our community. He was participating in AI and Software Development Summit, and now he joined us for React Global Summit as well. He is the developer advocate from Refactor AI, and he will tell us really nice topic: hybrid rendering, merging the best of both worlds with Vercel and Astro. Welcome to the stage, Vadim.
Hello and welcome to my talk. This is not the first time I'm speaking at the Geekle event, and it's always amazing to be here. I love the event, and I'm thankful to event organizers for putting this event together. So I hope you're having a great time, so let's get started. So my talk is about hybrid rendering with Astro and Vercel. And before we get into the talk itself, I would like to introduce myself. So my name is Vadim Smirnov. I work as a developer advocate at a company called Refect.ai. And before doing advocacy, I was a front-end engineer. I started back in the vanilla JavaScript and jQuery era. And then I worked with Angular, Node.js, Gatsby, Netlify, Vercel, any tool you can think of. I touched on that. So I had great fun playing with these tools. And eventually I decided that I want to pursue my dream into creating educational content and helping developers to achieve their dreams and be more confident with the project they're working on and basically be more confident in their career. So I live in a place called Gdańsk, which is a small city. Well, it's not really small, but it's not the huge city in Poland. And it's a Amsterdam simulator. It looks really cute. There's a bit of information to make this talk more personal, so you can get some info about me, who I am. And as I mentioned, I work at a company called Refect.ai. And at Refect, we're building a customizable AI coding assistant. It consists of the toolbox, which is a feature that consists of a set of pre-built commands designed to solve certain actions, like fixing the bugs in the specific block of code, or fixing the naming convention, or making the code shorter, or whatever else. And also you can make your custom commands, which is also amazing because if you know that you're doing some kind of repetitive action, you can basically move it to a pre-built command for yourself. Obviously, since we're building a coding assistant, code completion is the core of our product, the main feature, the mostly used feature. Besides that, we have AI chat, an integrated chat in your IE, and we also offer a self-hosted version of Refect, which you can get by running just one Docker command. And inside this self-hosted version, you can fine-tune models using your own GPU to kind of make the more personalized experience, to kind of train the model on your code base so it gives more relevant code suggestions and response in the chat with awareness of your code base or toolset that you're using inside your project. So feel free to go to the website. You can explore it, or alternatively, feel free to connect with me on X or Twitter, or on LinkedIn to talk about Refect or web development or something in general. If you feel like just chatting, I'm always open for a chat, always happy to connect. So feel free to do that and hit me a DM and let's just basically talk and get to know each other. I'm always happy about that. But now let's talk about the content of this talk. So I recently got into the storytelling aspect, and it's really interesting because telling stories help to kind of build the structure of the talk. So this talk will be following the same guidelines, the same rules, and I will be doing the storytelling aspect in this specific talk. And we will start from the Jamstack, how it became popular, how we were building websites using tools like Gatsby, for example, or Next.js, and basically the rise of static site generation. Next, we will transition to React and Next.js, and this is a part of the history because Next.js became a de facto standard in web development, and the SSR, which is server-side rendering, became an interesting solution and kind of solved the problem of limitation that Jamstack kind of had. So we were able to do a lot more with Next.js, and we will touch on that. Next, we'll talk about Astro, how Astro brought the fun of building Jamstack applications and how it had like a full complete package and the framework that basically we love right now, and it's only keeps growing and getting better. So this is going to be a big part of the story because we will see the hybrid rendering in action with Astro. And this actually leads to the next part of this talk, which is hybrid rendering. And we will answer 3 questions about hybrid rendering. Basically, what is hybrid rendering? The next question is why? Why should you basically care about this? And the next question, the last but not least, is how? How do you use it inside Astro and with Vercel specifically? But now let's get started. And the first part of the story is about Jamstack. So Jamstack is how it all started for myself, because I remember back in the days we were using React for most of the web projects. Like even if it's a simple landing, we were still firing up a React app, and it felt a little bit like an overkill because we were getting a lot of tools which we didn't use, and it also spoiled performance because we needed just the simplest and most straightforward approach possible. And this is what Jamstack basically did. It solves the problem of the complexity, and it also delivers what you basically need. But now let's talk about the Jam in Jamstack, so the abbreviation itself. So it stands for JavaScript to handle dynamic functionality in your app. The next part is APIs for server-side operation, and it stands for A, obviously. And the last part is M, which is markup for static HTML files, basically the stuff that you see in your browser for the representation and UI purpose. And here is a quote from Matt Billman, who is a huge person in web development in Jamstack specifically, and this quote summarizes Jamstack pretty well, so I included it in this talk. Modern web development architecture based on client-side JavaScript, reusable APIs, and pre-built markup. And that's basically it. This is all you need for fast and well-performing projects. And one of the important aspects of Jamstack is static site generation. This is really important for this talk and really important of the whole era of fast applications and fast websites that we're building. So I will explain static site generation with this image. So here you can see on the left side, it's a monitor screen that represents user client, and on the right side, the server, basically where your website is hosted. And when a user fires a request, basically accessing URL where your website is hosted, the server responds with the pre-built HTML. So the whole process is request, response with the pre-built stuff. And that gives us a set of benefits. This is not the full list, this is just a part of the important stuff. If you want to explore it deeper, you can go to the Jamstack website, and there you can find the full list of stuff, the full list of benefits, and a deeper level of information, because Jamstack is a big topic and it deserves a separated talk. So I will just do a quick refresher because this is important for this specific topic. So performance basically is an obvious benefit because we give user a set of pre-built HTML. And obviously we're not building it on each request. We're not re-rendering stuff. It's static and it's fast. The security, because it's static, is an obvious benefit that you're getting with Jamstack, and also developer experience because it's simple, it's very straightforward, the implementation was not difficult, and the whole architecture of Jamstack is built around simplicity and designed this way so you don't waste a lot of time into setting things up and basically focusing on developing the product itself. And as the result of that, we get fast and fun experience. We're not struggling, we focus on the cool stuff, and we're focusing on delivering the project itself, which is fantastic. I really enjoy that. Obviously, there are a lot of controversial opinions about that, but as my personal opinion, I think Jamstack is amazing and I enjoy using it till this day. But Jamstack obviously is not for any project you can think of. So Jamstack solves a specific problem. It has a specific use case. So Jamstack is good for a certain type of products. So it's not designed to be a foundation for really complex web applications. It's mostly for landing pages, static blogs, e-commerce applications, and some more categories. But it's obviously focusing on something more static that doesn't require a lot of dynamic interaction and a lot of re-rendering cycles. And this is the moment when Next.js and React kind of started to transition into something different, something bigger. Next.js slowly became a de facto standard for any web application you can think of, like developers, when they were firing a new app or starting a new project for a client, you immediately go to Next.js because you know that it has everything inside the ecosystem and you don't have to worry about if you have the right tool to solve the problems of your client or your own. And this is a screenshot from the Next.js website. You can see that it offers a lot of things that you need to make sure that you have everything inside your project to deliver the top performance, and all of the best features are available in one set, in one package. Obviously, this is a screenshot that it was taken by a recording of this talk, so it might change in the future. They might introduce more things, and obviously they will do because Next.js is only growing and becoming better. But you can get the idea that Next.js has everything. And one of the things that make Next.js look different from other Jamstack products is server-side rendering. So it stopped being statically generated and became server-side server-side rendered. So allow me to explain the server-side rendering approach compared to the static approach. So if you remember, this is the image from the previous slide we used to explain the static site generation. If the user fires a request, server responds with a set of pre-built HTML. But with server-side rendering, it doesn't respond with the pre-built HTML. It actually generates HTML pages on each request. So this is a huge difference. Obviously, the load time is a little bit bigger, but that allowed Next.js to be used in more dynamic apps with more interaction and more dynamicness to it. And here are some of the things that developers and me personally love about Next.js and server-side rendering. First of all, is developer experience. The Next.js toolset, if you remember the screenshot of the Next.js website, the toolset itself makes excellent performance look effortless because you get a lot of tools out of the box that help you to do complex things in a simple way. So that obviously makes you move a lot faster and with more confidence. The next thing, it's dynamic, not just for simple landing pages, blogs, or e-commerce projects. Next.js expanded into something bigger, so it became like a de facto standard, like a replacement for Create React app. And the last but not least, it's popular. So basically different products prioritize Next.js support. So if you're using any kind of CMS or any library you can think of, they prioritize Next.js support and make sure that you can use it inside your Next.js project. And that's obviously amazing because you have like a huge ecosystem and you can use a huge variety of tools inside your Next.js project. And you can make sure you have the right tool set to solve specific problems and to deliver great quality of products. But this was the moment when new era began. So the Astro became a thing, and Astro actually brought the enjoyment I personally and a lot of developers had about statically generated sites and Jamstack in general. Astro allowed developers to use SSG, static site generation, with refined approach. So let me do a quick recap of the whole thing that I think is important in Astro. So first of all, Astro is really simple. It's not difficult to understand the architecture of Astro. It's simple and straightforward, so you can get started really fast. The next part is developer experience. Astro is built by developers for developers. So developers understand the problems we are having and they're creating a product that actually does the job. So it's amazing. It's really simple to understand how to do certain things, and it's really effective. The next part is community. Community is a great thing, and I really love Astro community because it's fantastic, it's really friendly, and you can actually meet people who are creating Astro. They mostly hang out on Discord, but obviously you can find some other sub-communities on other platforms or websites, and you can always get an assistance and support from people who are already figured out some problems you might face at this specific moment of time. So Astro community is amazing, and it's really enjoyable to see how people help each other build amazing things. And also it helps Astro team to move a lot faster, to get immediate feedback if they like something or not, and how to shape product for people who are actually using it already. The next part is integrations. Since Astro became really popular, the same story as with Next.js happened. So a lot of companies and a lot of products prioritize Astro support, so you were able to use CMSs and other libraries inside your Astro project, and that was amazing because a lot of integrations allowed to expand this whole Astro ecosystem into something bigger. So that was a great thing. And since Astro is focused on static site generation, performance is not a question, is not an issue. Obviously, with Astro, you get a fantastic performance out of the box. And last but not least, and something that I personally enjoy, is starters, because Astro offers a lot of starters and community builds a lot of starters as well, which is a great thing because you can also explore Astro not in the documentation only, but also see it in action, how it actually works. You can see like production ready projects and you can play with it to understand all of the moving parts and how to work with it. And also you can use it to kick off any project of yours. So you can use starters to customize those and make it your own to deliver projects a lot faster. And to summarize, Astro brought us static site generation at its finest. So it's a full package, it's a complete ecosystem, and it's well thought. It's not just some kind of, hobby project. It's a complete amazing product you can use confidently for your clients or for personal use. And also one of the fun things about Astro, which I personally like, it's UI agnostic. So whether you're using React, Preact, Vue, or Svelte, you can do that because Astro does not limit you to specific framework you're using or prefer using. You can use all of that inside your Astro projects. And just to show that in action, so here you can see like these lines, which is like if you're familiar with the concept of front matter in Markdown, it's exactly the same. And below that, you can see the HTML snippet of the page itself. So inside this front matter part, you can put your React components, for example, if you're using React, and you can use those directly below in the HTML, like the markup part. So this is really straightforward, really simple, and doesn't limit you at all. But there was still an issue and question we were facing. It's the basic question, like it's either static site generation or server-side rendering. So it's one or another. So at the end of the day, people who need a lot of dynamic stuff in their applications, they were going to Next.js because it offers better support for server-side rendering. And if they want something more simple or just more static, they use static site generation. So it was like one or another. And that wasn't a big issue, but there was some kind of limitation still. And the same stuff people faced with Jamstack. It solved certain problems and it was suitable for certain type of projects. And hybrid rendering actually solves that. And this is an interesting feature, actually recent feature of Astro. And I really hope a lot more people can start using it after listening to this talk, because that will allow you to build more cool stuff with your Astro project, and you will not treat Astro as static only, simple only. So what is hybrid rendering? Hybrid rendering is basically the way of combining static site generation with server-side rendering, so you can use both inside one project. And just a small recap, static site generation is the process of sending a user a set of pre-built HTML when the user sends a request, and the server-side rendering is the process when HTML is generated on each request. And you can use both of those in one project with hybrid rendering. And with Astro, we have to use adapters. And at the moment of recording of this talk, there are 4 adapters available, which are Vercel, Cloudflare, Node, and Netlify. All of those are awesome. We'll focus on Vercel in this talk. And adapters are needed for you to use server-side rendering part. But now you can say it's all good and well with him, but let's see it in action. Theory is great, but we want to see actual code. We want to see it in action. So let's do it. Let's see it in action. So if you never created an Astro project, here's an intro for you. You can do that by running npm create astro at latest or yarn or pnpm, whatever you prefer using. You can create Astro with this command. You can go to the documentation for a specific command. And to simulate the deployment process, we can run npm run build. But be aware that you need to be in the folder of your projects. So you cannot do it outside of your project's folder. So if you run npm run build, you will get the folder called dist, and it replicates the structure of your project. Basically, the folders represent pages, and inside these folders, you have the index.html files. So it's really straightforward, really simple, really what you need for statically generated websites. But now let's talk about adding the adapters. So you can do that, and yeah, in this talk we're focusing on Vercel, but you can go to the documentation and look for the actual steps for other adapters. But for Vercel, you need to run this specific command. It's npx astro add Vercel. And after running that command, you will get this response in your terminal. And this is one of the things I really enjoy about Astro. Their CLI is fantastic. It's really talkative, and you get a lot of feedback. You actually know what's going on, and you have a lot of info, and you can see the actual changes. And in this specific case, you can see that Astro will make the following changes in your config file. And astro.config file is the heart of any Astro project. This is really important. All of the stuff that we will configure will go there. And if you're not familiar with Astro, you can basically go to the documentation and explore what astro.config file is. But as you can see here, we add the import of Vercel from Astro.js Vercel serverless, and we also add the output property in the config itself, and we set it to server. And now if we run the same command to simulate the deployment process, npm run build, we will see a little bit different things happening. So we will see that the Vercel folder will be created, similar stuff if you're working with Next.js project. So you will get folder with this server-side render app. So it's the same stuff as dist in the previous example, but in the SSR way. And now you can ask, wait, what's hybrid about it? It's either statically generated or SSR, it's same problems, nothing changed. Like, what's different about it? Why hybrid? And here are more actionable items for yourself. So as I said, when we added the versal adapter, it added the output property in our config, which is server, a screen server. And it's mostly suitable for server rendered apps. So if you have a lot of dynamics things happening in your application, you should keep it this way. This will work amazingly for you. But obviously, even if your project is very dynamic, you still can have a lot of pages that are static, for example, an about page. So it will have just text, some kind of images or any kind of information, and you don't really need it to be re-rendered all the time. You're okay with it to be statically generated. And you can do that without actually changing it to a statically generated website, the whole Astro project. And you can do it by adding this const variable, prevender, which is a Boolean variable, and set it to true. And now this specific page, which is an about page, will be statically generated. So everything else still follows the SSR way, but this specific page will be rendered statically, which is a good thing because we don't need it to re-render all the time. But now let's look at a little bit different thing. So if you have the app that is mostly static, but you want to have certain things dynamic, certain pages or certain components, you can use hybrid as a value of the output property in your config file for the apps that are mostly static. So this is an example of the config file. You can see that before it was a server and now the output is hybrid. So this is the only change you need to do in order to make it mostly static and less dynamic application. And in the pages or some kind of components where you need dynamic functionality, server-side render functionality, you use the same approach but in a different way. You set the variable pre-render to false, so it's not statically generated anymore. It follows the SSR way. So now let's do a really quick refresher of what we learned in this talk, just to summarize it and kind of refresh and structure a little bit better in your head. So we started with Jamstack. We talked about SSG, which is static site generation. We discovered how it works under the hood, why is it cool, and why is it suitable for a certain type of projects like landing pages, blogs, or e-commerce apps. Then we talked about Next.js and server-side rendering, how it solved the problem of static websites, and how it became a de facto standard for web applications that people are creating nowadays. The next part was Astro. Astro really redefined the static site generation. It brought the enjoyment back, and it really was amazing and still is amazing to work with Astro, and it only gets better because Astro team is doing a great job and improving the product all the time, so it's always enjoyable to see the changes and improvements in Astro, and it's already a solid foundation. And if you need to build a web application with Astro, you can move confidently and without any issues. And then we discovered the hybrid rendering, so basically how to combine SSR and SSG into one project. And we answered the question, why? Why should you care? Basically, if you have mostly static applications and you need some dynamic functionality where SSR makes sense, hybrid rendering is a solution, or the other way around. If you have a very dynamic website or application and you need some parts to be static because you don't want to render that all the time, like about page or whatever else, as the solution to that. You can use the best of two worlds inside one project, and this is fantastic. And we also covered how you can actually do that. We saw that in Astro you're using adapters, and we saw Versal Adapter in action, how you actually install it. We saw the output, how it changes the default deployment of Astro project, and how to use it, and how to use the hybrid rendering inside your project, basically by using the pre-render variable inside your components or pages. And this is mostly it. I'm really thankful for the opportunity to speak in front of you, for you, and with you. It's always enjoyable to be at the Geekle conference. Again, I'm really thankful for event organizers for allowing me to be a part of this. But now, thank you so much for spending time with me, and I'm ready for your questions.
Thank you, Vadim, for your input. It was really nice presentation. And also, I would like to encourage our audience to type your questions in the chat. Vadim will be live with us during the Q&A session, and he will happily answer all of your questions. And now it's time to invite our next speaker, who is Leonardo Negrarios. He is Senior Frontend Engineer from CodeMiner, and he is live with us today. Let me invite him to the stage. Hi, Leonardo. How are you today?
Hello, everyone. Hello, Tia. How are you?
Great, great. Nice to see you here. So yeah, Leonardo's topic is handling data with React Server components and server actions. So I won't take more of the time. Let me add your slides to the stage.
Okay.
Yeah, I think we need to increase it a little more.
Okay, just a bit more. Okay, is this readable already? Let me just increase more here. Oops.
Yeah,
nice.
Better. Great. So let's start.
Nice.
Thank you. Stage is yours.
Okay. Thank you very much. So, hello everyone. As you said, I'm Leonardo, and I've been working with front engineer for quite some time right now. And today I'm going to talk to you about React Server components and server actions, and how does everything integrate with the data flow of our application, from the data fetching to the notations, from updating the data on your screen, and just the cycle of data that we have on the future of React, because server actions are almost there. They are already usable on Next.js. React Server components, it's just like React Native is just right there, on our doorstep. So I think it's a good thing to learn right now. It's a very valuable skill to add to our skills, to our tool set, actually. Yeah, a very valuable skill to add to our tool set. And let's go. So first, I created a project to use it as an example. It's a Next.js project with Tailwind and Shadcn UI. And with this project, we'll take some steps, and I prepared a lot of commits on this project here. And we are the first one. That's basically the post fetching, but as we progress, we will going to progress the commits, and they will be all available for you to check out on GitHub later. After this talk, you can just go there on GitHub any day, anytime. It will be available there. If you have any questions, we can ask later too. But anyways, let's go to what matters. So first, I have a small backend running here. It's just this db.json in a list of posts that we'll use for this example. So I'll start and run it. Where's it? Okay. This is my JSON server running. Very nice. And now we will start our Next.js server. npm run dev, and then we are starting it. So I'll just open this link here. Oh yeah, it's already open. Nice. So as we can see, it's a very simple page. It has a listing of posts. Show the title, show the post content, and how many views it have. And if you see the code, we have this post component. That's basically the list. A very simple component, just a map, and there's it. But there's a catch in this component, this page.tsx. I don't know if you are already familiar with the regular data fetching in React, where we have a user query or we add some use effects, and there's a lot of ways to fetch the data, a lot of libraries that do it, but they all boil into fetching the data as soon as the components render through an use effect hook. But on React Server components, we do not need to worry about use states, neither use effects, because both use state and use effect, they are actually client component hooks. We cannot use them on server components. So if you cannot use them on server components, then how do you fetch the data on server components? Well, this is an example of it. If you see, we have this first part here, this component is async function. So we can use async await methods inside of this function. And this is exclusive to React Server components. We cannot declare client components with async function as async functions, just on the server. And since we can call as async functions inside of our server, we can also call async methods. We can just do post await fetch some data, such as we have here. We have this response equals await fetch my post that comes from this URL from the server that we were running on our terminal, and then just do post await response.json. This is a method from the fetch API where we turn the response into the data that we want. And then I'm telling that my post will be an array of posts. This is the nice TypeScript part where it tells me, you can see promise post array, where we can see what these functions return. We can even see the post type here. It has a string, it has a type, it has a body, and it has views. And then that's it. We do a const post equals await get posts, and then we can send it to a lot of places. And inside of Next.js, we can even add a loading handler. We can take here and we create a new file. Let's call it loading.tsx. This is default from Next.js. Every time that we added loading.tsx, it will create a loading component. We can just export it from function, loading, and then we just do a small return. Oops, this must be string. It's loading, and just this. And let's see how it does behave. And if you do a refresh, oh, it's too fast, the server to show the loading. Wait a moment, I have to add a timeout here. This is a small technique that we will be using later to kind of create a small delay on the application. Okay, so timeout, and then there's a timeout also. I will put here 5 seconds to load, and then do resolve. Okay, this should be enough. So let's try now. Okay, oh wait, it's not loading. Oh, I forgot how to do it. Wait, I have a code here that takes it. Let me just, I'm just missing the syntax here. Let me just get from one commit. I will do a bit of spoiler here. This is not many spoilers. I hope so. Oops, let me just get here, git checkout, and take, oops. Okay, I just want this piece of, oops. I just want one piece of code. Where is it? Did I change it? Git checkout. That one, yeah. Page, where's the delay? Post, create post, yes. Is this, oh, I forgot to set the await. That was it. So let me go back here to my, save this. Let me just save this piece of code because I forgot about the await there, sorry. And then let me go back here to our here. To our git checkout. Okay, we can just do this dash pop to return to our changes. So yeah, I just forgot to do the await. Is that right? Yep, is that right? I just forgot the await. My bad, sorry. And then see, we have this loading. And then after 5 seconds, it will go back to our code. Oh, I forgot to resolve it, right? Yeah, let me just copy and paste here. Forgot to resolve. It's easier when we already have it done. Let's try again. Okay, now it fell into the loading, and I'll see the post. So this is basically the loading handlers that we have through Next.js. And we can even, instead of doing this loading, we can do it manually by using suspense boundaries. They also come from React. Because this loading.tsx, what it's basically doing is adding a suspense boundary here that basically will say, hey, while everything is fetching there, we will show this fallback. Let's see, fallback. I will just put also a loading. And this will do basically the same thing. When we load here, we also this loading 3 dots. Basically, when we create this loading.tsx, we are involving the application into this suspense boundary. The Next.js does it automatically for us. But yeah, that's it. That's the basically of data fetching on React Server components. It's just a async function that we put there, and that's it. So let's go to the next topic, which is mutation. So for this, we will create a small form to create posts. let me just, I have to stash everything right now. And then you see, okay, we go to our create form post, and I have to install some dependencies because there's some points of the application where we just actually had to, okay, to start it there. See now, it's compiling. That's one thing about Next.js. The first load of the page is a bit slower because it's compiling the page, but then the next loads, and you can see here, it will be a bit easier. Yeah, it's just reduced from, I don't know, 11 to a bit less. It takes some 12, and then 12 milliseconds to load, and then now only 2 milliseconds. I mean 2 seconds, because it compiles the page and then it gets faster for the next renders. But anyways, I'm digressing. So yeah, here's the create post. It's a very simple form. We open you have this button that opens this dialog that has a title and a body, and you can see it. The create post component. It has those are all Chatien UI components, so you do not need to bother about them. But we have here the button that opens the dialog, and then have a form with a label and for title and an input, a label for body, and its text area. They're all connected. We have this button from type submit that creates the post. So you can see, and you can write some stuff here. Sorry. And then if you create post, nothing happens because it's not connected to our backend. So the next step is to create an action that when you click on create post, it will send a request to our backend and it will create a post. So we can take, let me see, to the next commit. And then let me check out here again. Okay, and now we are on the server action commit. So this is the most basic usage of a server action. We have a function that's an async function, and it has this user server declaration on top of it. There's also another way to use it, but we will be seeing it later. So, okay, we have this user server declaration on top here, and then what we do? We basically do what we do in all other places where we do like a submission to our API. Get the data, we transform it into the data that we want to put on our body, and then we just send it. But where is this being called? That's the question. Where do we create our post? Well, this is a form action. This is actually a new React thing that the action prop of a form, instead of just receiving an URL, if you are an old developer that worked with PHP or something like this, you might remember those action. You might remember those actions as a string that's a URL that sends a post to another place or a get, and then those actions they trigger when those submit. It's very similar to doing an on submit and then place a bunch more things, but the action is just a bit more straightforward. It's like the way the web dev worked before, and then it got a bit lost on its way here because of, I don't know, a lot of JavaScript that were happening on the UI, and now it's being reused again. But instead of just receiving a string, it also can receive a server action, and the server action receives a form data. That's basically the form that we have here on our form, and that's it. As you can see, we still do not have to write single use state or any state management or anything. We just create a function and we call the function here. And the nice thing about server action is that although we are calling it from our client side, when we click, we are calling it here from our client side. Well, let me just close this Geekle. We will not use it anymore. And although we are calling it from our client side, this function is happening in our server. If I put a log here, let's see, console.log, where is this happening? Where is this function happening? Where is it running, actually? Not happening. Where is this running? So I will create a post here. I will also open my console, and we will see. Well, no log here. So where's the log? is right here. Where is this running? It's running on our backend. What is happening is that our frontend is sending a post request to our backend, to our frontend server. Like this is the post style equals to the content, and the body equals to another content. And this post is then, this function is being run over here. One of the advantages of having this React Server components and React Server actions is that this actually reduces the amount of JavaScript that we're sending to our clients. So if your user is on a place there's bad internet connection or have limited amount of data on its mobile phone, then this is a nice thing because we are sending less and less data to the client, and the page loads faster, it runs faster because it needs less processing. So this is a very nice thing. We could even disable the JavaScript front page, and this would still run because this is just a small HTML file. And when I create a post, I can even show you it's just where's the form? Oh, I have to open the form actually. Sorry. If I open the form and we inspect this form, yeah, this action, it's here. This way, yeah, this is how it's be declared here. But when you do it, it basically will just call a post request, just as the old form action, but React does a bit of processing here and transform this function into the URL that hits our backend server. So, okay, not our backend server, our frontend server in this case. But yeah, this is the most basic usage of a server action, but it might sound a bit simple right now because this beginning is a bit simple, but when it starts to integrate everything, it will get like more a bit complex. So, okay. So for this next step, we will add a delay to our application because if you see, this is very, very fast. When I create a post, it creates almost instantly. And it creates and it closes here. I do not like it. I wanted to show like a message that it's creating a post, like I create a post and it shows a spinner or something like this. So, also when we create here, we can see on our db.json that they are being created here. I will erase this because we do not need this data right now. Okay, but anyways, so what are we going to do is to add a delay, just as we did before, because unfortunately running locally is just too fast. Oops, stash everything. Oh boy, sorry. Running locally is too fast. We need to slow a bit down our application. That's why we are adding this hard-coded delay. Oh, did I? Oh, sorry, I went too far. I forgot to add the revalidation. Let me just go back a few steps. Yeah, and we can see there's another detail here. When you create a new server, a new post, new post, it doesn't show at all. We created it, but there's no sign that it was created. If you refresh it, then it shows. But this is not what we want. We want to create and then update the UI. So that's why we do this revalidation of the data. This is a Next.js specific API. Let me get here. Okay, post revalidation. So this revalidate tag post, this Next.js specific API. So what we're doing, first, we go back to our data fetching, and then have these options on the fetch API. This next, it's kind of like a next extension to the fetch API, and we will add some tags here. In this case, we're adding tag posts to kind of name our cache, like say, hey, anytime that we want to say that this data is invalid and it should fetch it again, then we do this revalidate tag post, and that's how we will update our data. I will create a post, new post, and new post, and yeah, it's already there, very fast because it's local. But I will create another post here so you can see another post. Oh, sorry. It's like, sorry. And there it is, our new post. Let me just clean the DB, and I think I have to rerun it before. I can just delete everything. Okay, now I have to restart it to update it. Let's see. Oops. Okay, it's on again. So yeah, that's the basic of revalidation. So let's do a small recap. First, we fetch the data. We add a tag to this data, like similar to if you already use React query, this might sound very similar because in React query, every time that we have a query, we have to add a query key to it. That's very similar to our query keys in React query. We add this tag, and then after doing an action that might change the data from related to this, that might change some data related to this, then you can do a revalidate tag with the tag that we already added there, and it will refetch again. Like if you go to our logs, let me just create a new one so you can see some updated logs. And create here, new post, create post, and then you can see we did some get here that revalidates the tag. You have the post, so it's here. It's already updated. But in this case, as I said before, this is too fast to see some interesting some interactions that we have with the other hooks. So that's why now we will add a delay to our application. We need it because in the real world, sometimes the requests are a bit slow. Sometimes we do not have enough bandwidth, and it happens. Or sometimes we are dependent on some third-party APIs that might not be the fastest. So that's why now we have this new post, then we create it, and then there's small delay, and then it should update. Yeah, now it updated. So for the user, this is not a very good user experience because the user clicked the button and then he got no information of what's happening. Like, okay, I clicked the button, nothing showed up. What's going on? So we will utilize our first new React hook to show the user what's happening right now, if it's failing or if it's creating the data. You add a new one to see what's going on. And this will be the user form status. It's a very nice new hook. Just go to the commit. Yep, this hook. Let's go here. It's this use form status. That's it. Also returns some other data like this data. That's the data that it returns 4 elements, if not mistaken. It's the data, the action, and it's the method. Yeah. These 4 are the returns of use form status. It must be called in a component that is under a form element because it takes the status of the parent element. In this case, this is form here because we have form. And then you have the submit button. That's this. So this use form status is related to the parent of this submit button. In this case, it's our form. For this example, we will just use this pending state. What that means is that if our form is on doing something and it's not over yet, this pending will be true. So while true, you show saving, and if it's false, we show create post. Also, I added this open and set open state to our dialog because before we were controlling it with just click the dialog close. I mean, just click the create post button and close the dialog. Now we will just close the dialog after creating a post. So let's see how does it looks. Create a post and another post. 1, 2, 3, 4, and then we create post. It's saving, and then after it's saving, then it closes, and we have here another post. 1, 2, 3, 4. So this is how to use the use from status. We could even go further and take the submit button and create its own component. Maybe create a component called submit button, and then we can reuse it everywhere. You could say something like, hey, this will just have children, and then it will be props with children. And then we take, you can put this You can also pass some wording here, but we could just do submit button, and then it will be create post, submit button, and then we can just say something like this: children create post. And this could be reused everywhere. You could just use it in any form, in any time, and it would just work. That's one of the beauties of use from status. Just work, and yet you can see we still didn't add any use state near use effect because it's still not needed. You can just do all of this flow with just the you have a state for the dialog, but it's not related to the submission of data. It's just to show this open or not, but this is not related to the actions. Actually, I just use the dialog because I find nice. But anyways, I digress. Sorry. So yeah, this is the use from status and using it the scenario. And we also added the delay here. Let me show you, because I already showed you the delay before, but also there's another thing. If you see, do not have the create post action be declared here. You actually have it. Where is it? This function in this file, I mean, called post.ts that I put in this folder, this actions folder. And what this create post does now, it's basically the same component. It has this delay here as we have had before, but the user server directive is not anymore in this place. It's actually here in the user server. Why is it? Because this create post is now a client component, and we cannot declare server functions inside of client components. Before it was a server component, and we could do some function here that would be, let me see, user server. You could do this before, and because it was a server component, but now we cannot do it anymore. We just comment this for a bit, and let me save, and we will have an error. Let me show you the error. Okay, it's not allowed to define inline user server in client components, so we cannot do this. This is forbidden. So the way to deal with server actions inside of client components, you'll be having a separate file, and separate file must have this directive on top of the file. The first line must be this user server, and what it does, it marks all the exports, all the functions, everything here as a server action. If I put like a const sum equals 1 + 1, this is a server action right now. Because this has user server here, this is a server action. There's no running away from it. This is a server action. If I use it anywhere, this will be a server action because of this user server directive. But yeah, that's it onto the use from status. And now we will also add some message to tell our post that our post was created. Because imagine that we are on a very, very big list. Create a new post, and it's right down the bottom. And I didn't see the post. For me, it wasn't created because it's really here, and I can see it. So we have to tell the user, hey, so the post is ready. So let's go to the next step. Let's just add a post message. Oh, I have to do another npm. Or not, I think I should just rerun the server because we have a new component. Or is it though? No, we'll try next time. But anyways, yeah, we have a toaster message. So let's see how the code looks right now. I added to our layout component this toaster. It's also from chatcn. But all the components from chatcn, they are in this UI folder here. It's very easy to add in. This is all generated coded from chatcn. I think this is very nice because we do not have to import any new library. We just basically added the component to our own project, and then we can customize it as we want. But anyways, we have this toaster here on our layout, and then inside of our create post, we have this use toast hook and the toast function. So what we do now, we create our post. This is an action from the form. We get the data. We create our post as we did before. After we are done creating our post, we close the dialog, and then we show this toast, tile, new post created. So let's see how does it look. So you see, it's all fitting together right now. By the way, do not be afraid of error messages. Error messages are there to help us. So it's better to have an error with an error message than an error that shows nothing. So I'll think about it. So let's go. I'll create a new post. I'll call it new post 2. No, 3 now. New post 2.3. You'll create it. You're saving it. And after you're done saving it, it shows the warning, hey, your new post was created. And there it is. So this is starting to look much better from the initial UI where the actions were just happening and there was no telling us what is this doing. So yeah, this is already looking nice, but we could do better, because if we see now, we can create an empty post. And this is an invalid scenario. Why a post would have no title or no body? Who wants to read that post? So this is a failure on our application. So now we also have to add some validation to our project. So let's go and do some validation. Oops, just reset her instead of stashing everything. Oh, oops, I always forgot to do the right thing. Okay, right now, let's do some validation. So it also looks the same, right? So let's see our post, how it's looking. Oh, we have some new thing here. We have this const validation equals validate post. If the validation is not successful, we return this error validation.message. And the rest of it is just the same. So let's see our validate post. It's a very simple method. We could use like Zod or some other validation library. I really enjoy Zod. I would recommend using it. But since I want to keep this as simple as possible, I just did a very rudimentary validation here. I'll check, hey, if the new post doesn't have a tile, well, error message tile is required. If the new post doesn't have a body, error message body is required. And then if we have an error message, then our success is false, and our message equals to the error message. And if everything is successful, then success is true, and the message is the error message because it will be empty. Okay, so if validation.success, if it's not successful actually, then we render the error. So we can go back to our application, create a new post, and if create it, whoops, what happened? Because I created create post, it showed the new post created, but the post was definitely not created because it did not pass the validation. It's just ended here, returned here. So we have to do another thing now, that let's also add an error toast to at least show, hey, this thing is not right. So let's add an error toast. And that's what changed now. Our post is still the same, but let's see our create post. Oh, now we get the result of our create post. Here, our result equals await create post data. And then we have our error and our, if you have an error, that's basically the result of this validation. We have the toast here, and if we do not have an error, if we have a success, actually we close this model, and then we show the new post created. So let's see how it looks. So yeah, the tile is required, the body is required, nice. Now we just have a body is required, and we also have the opposite. 2.3, tile is required. So this is starting to look better because we are not creating the post when we are showing the user, hey, this is not right. And then we put everything together. Then we have the post creation, the new post created. Very nice. So this is our current error handling, but we can also do better because it's nice to show on the field where it's wrong, because this body is required. I mean, I'm looking here and then I have to look back here, then I have to look here again. This is also not a very good UX. So we also need to improve our UX, and to improve it, we'll take this error message and we will not only show a toast, but we will actually show a message within these fields to show where is it wrong. So let's take here. We'll use now another hook that is called use from state, but beware that this hook actually changed the name in the last version of React. It's called use action state right now, but since Next.js still didn't update to the latest of the latest React version, because it's still canary, still under development, so it still takes some time to update things. So it's still called use from state in this current version of React, but beware that if you're watching this in the future, this might be called.
I'm so sorry to interrupt you, but you're 6 minutes out of the speaking slot, so you have like 4 minutes to wrap it up. I'm so sorry.
Okay.
Thank
No
you.
problem. Thank you very much. It's almost done there. But yeah, and this use from state, it takes our action here, our create post, and then it takes also initial state, and we can take this. What's the goal of this use from state? Is to basically take the result of our form action, and then we can use it inside of our component. Let's show you how it's working here. Okay, click create post, and then I create the post. It now will show, instead of the toast, it will show the style is required and the body is required. And this is a much better UX because we are not distracting our user. We're just straight out looking at it. And that's it. We take them. Let's see how it works. First, we have the use form state. It takes the first argument is the form action, and the second argument is the initial state for this form action. So in this case, our form action, it returns like you see the post signature. It takes this error and data, or we have the data but no error. So I started with the initial state of the error being null for tile and body, and the data is undefined. And now there's also a small change in our create post that it takes an first argument that's the initial data of this create post. That's basically this, but since it does not have a use for our use case, I just put an underscore here with any because we're not using it at all. So I didn't want to worry about the typing. So I just did this. But now what we'll be doing is that instead of just having this form action and after form action ends, then we do something, we'll take this state, and when it changes, we have this use effect, and when the state changes and the data exists, or so it's a success, then we do the classic set open false and the toast. But we also can use the error here. We have this error.tile, we have an error.tile, then we show the paragraph here with the error, and we have the error.body. We also show the paragraph here with the error.body. So we can see here again. If we create here 1, 2, 3, now this is okay, but this is not okay. If I do a 1, 2, 3 here, this is okay. Okay, new post created. One drawback of it is that if I do this, and you can see before, you saw before, and I add another post here, it does not clean it at the same time because this is just created after the action is done, this update of the state. So if I create a post and I do this and close and I create again, this error is still here because the state didn't change, because the state only changes after the action is done. And also one of the reasons that the name of this was changed from use form state to use action state is because several actions can be called outside of form actions. They're not something related to forms. They might be related to forms. They have a very nice integration, but they are not necessarily needed to be used inside a form. You can use it anywhere as long as it's wrapped by a transition. You have the use transition hook, and if you do a start transition and call the server action inside of this transition, it will work. The thing is that this form from React, this action is already wrapped by a transition in itself. So that's why we do not have to worry about anything. And yeah, I think that's it for today. We have we saw the use form status, We saw the use form state, that's now use action state. We saw the data fetching. We saw the revalidation of the data within Next.js. And that's it. All of this project will be available on GitHub. I'll send the link to you later. And that's it. Feel free to ask any questions. Yeah.
Great. Thank you, Leonardo, for the presentation. And we are ready.
Thank you very much for the opportunity too.
Thank you. So I'm inviting Vadim to the stage. Hi, how are you?
Hello, doing great. What about you?
Also great. Thank you for joining us. So let's start. First question is to Vadim. How efficient are Next.js and Astro hybrid rendering for video games?
Well, I have a question for your question, actually. What do you mean by video games? Obviously, I mean, the use case of Astro and Next.js, probably video games, if you're planning to create video games, it's not the perfect use case. If you want to build video games, you will use different stack. But I mean, you can create something like browser-based, something simple, but initially it's not designed for the video games creation. So how efficient depends on what you want to build, basically. If it's something simple, web browser, you can do that. But if you want something like more advanced, obviously you should look into some different technology stack and something more advanced and something like, I don't know, Unreal Engine or whatever. So it's mostly depends on what you want to build. So you should look into what's your use case, what's the game plan, and stuff like that. So this is the summary for you, so you can get started and look for the right information for yourself.
Great. Thank you for the clarification. Next question is for Leonardo. What is the same as use like SWR?
What is the same as use like SWR? I don't think I got this question. What is the same as use like SWR? Sorry, I didn't understand the question.
No worries. So we kindly ask the author of the question to get us a little bit of context, some explanation, and we will get back to it. That's okay. Next question then for Leonardo. What advantages and disadvantages can I have when choosing Next 14 as my server?
Well, this might be a bit controversial, but I would not recommend using Next 14 right now, because I have been using from the beginning, like from the day they launched Next 14, I have been using it on a production project, and I don't think they are production ready right now. And I did it, I was an early adopter, but if I were you, I would wait for Next 15, the next version, because this will have the full support of React 19 that's almost released. So I would wait for everything to settle a bit and then just do it, because right now I think it has more disadvantages, like some styled components libraries do not work as good. I mean, Tailwind with ChatCN worked perfectly here, but if you want styled components, it will be a bit tricky. There's almost no documentation about it, so you face a lot of unknown problems. You have to debug a lot. You have to read a lot of the source code to understand what's going on. So the disadvantages, I think they eclipse the advantages. That's the server-side rendering and the small bundles sent to the client. I think the React server components are a very nice idea, but right now I think they're not just at the point that you can safely use them in your project and be like, hey, everyone, this is great, and you have no problems with it.
Okay, thank you for your recommendation. Next question is for Vadim. What interested you in exploring hybrid rendering with Vercel and Astro?
Well, initially, that was a question for myself. Like, I asked myself a question like how Astro advanced and what's new in Astro, and this was one of the features I didn't explore yet. And also, I noticed that hybrid rendering is quite popular in other frameworks, in other people use it differently in other stacks. And I basically really love Astro, and I thought that it has more opportunities and there are a lot more use cases, so you kind of can do more with Astro, and some people just don't use it as a goal opportunity to kind of move your Astro to a next level. Your Astro project to a next level. So I just thought, like, why not sharing this knowledge? Why not encouraging people to kind of use the most out of their Astro stack So just my curiosity and kind of encouragement for people to use the tool, the most out of the tool that you're using.
Nice answer, thank you. Our next question is for Leonardo. How does using React server components change how we handle data compared to other methods in Next.js?
So first, there's kind of a shift of the paradigm. We have to stop thinking about states. We're just like, hey, it's kind of more like a procedural flow. We fetch the data, we show the data, then we mutate the data, and then we update the data. It's like just it. There's some libraries that we use to do the fetching and then do the mutations. My favorite one is React Query. I think React Query is amazing. But when we use React Server Actions, we kind of reduce the amount of boilerplate code and the amount of code at all that we are writing, because we do not have to think about the loading state, because we already have the pending from the use from status. We do not have to think about creating an error state, because we already get the error from the server action. We do not have to create a state for the data, because the data already comes from the server components, just like as just a variable. So there's no use effects to fetch the data. It's just an async await. It's kind of like we write a program on, like a procedural program, just go step by step, and that's it. So we stop thinking about the life cycle of the component to start thinking about the steps, like is this, and then that, and then that, and then that. It's more like sequential, Yeah.
Great.
So that's it.
Thank you for the answer. And the next question is also for Leonardo. I think it doesn't have a name on it, but I think it's for Leonardo as well. Any way to use React Server components on React Native?
I have no idea. I didn't try anything or with RC in React Native, but I don't think so. I never saw anyone from the React Native community talk about server components. And there's always a bit of delay, right, from the time that features are released on React to when they are released on React Native, such as we have the hooks, for example. It took some time to go to the React Native community. So I still haven't heard about it. If someone has heard about it, please share in the comments, but I don't know. Sorry.
Okay, no worries. Vadim, do you have opinion on that?
No, I just totally agree. Yeah, everything what Leonardo said makes sense to me. So I was just nodding like, yes, that's correct.
I understand. Okay, next question is for Vadim. For someone new to hybrid rendering, what would be the first step to start incorporating it to their projects?
First of all, you need to kind of decide which adapter you want to use. You basically should go to the documentation and pick like one of the available, because there are 4 that are maintained by Astro team, and there are a bunch of, I'm not sure how much, but like there are some adapters that are maintained by the community. So you just need to pick one of those and just decide which one you should go with, and basically start following the docs. And basically my talk was structured the same way as the docs is structured. So you should start implementing the adapter itself, kind of just to make sure that it is available in your project. And then you just need to figure out how to use it in your project, what needs to be dynamic, what needs to be server rendered, or what needs to be static, and just basically just play with it. Just follow the rules of the documentation. Just figure out how to define the static stuff and how to define dynamic stuff, and then just move it from there and start to see and start to look into the output. Like if you run the npm run build command, you will see like what's static, what's dynamic, and you will understand how to decouple that stuff and how to structure it better. So yeah, my main recommendation, just pick the right tool we want to use and go to the docs and take it from there.
Great advice, thank you. And the last question for this Q&A is for Leonardo. For developers new to RSC, what would you say is the most compelling reason to start using them for data handling?
So I think the most compelling reason, so let me see. I think that's basically, it just gets simpler because there's less code to write in. I like to think that the less code we have, the less amount of bugs that we have. My favorite thing is to delete code. So when I see less code in my code base, I get happy. Although I'm a programmer, I have to write code. The less code I write, the happier I am. So if you're new to RSC, enjoy the less code that provides for us.
Great, thank you for the answer. And we just received 2 more questions. So yeah, we should answer those. It doesn't have a name on it, So you both are encouraged to share your opinion. With the introduction of React 19 and Next.js, is isomorphic React redundant?
I'm not very familiar with the term isomorphic React. Do you think more context could be provided with that?
Me neither. So we can ask the author of the question to get us some more clarity. No worries. And one more question. I think it's for Leonardo. RSC provides much needed performance and security benefits. However, does RSC completely eliminate the need for other client React hooks such as use state or use effects?
It kind of depends of your use case. So for the first steps of the example that we did here, we still had some use states that were most related to the UI components, such as showing the dialog. The use states still required there. And this has nothing to do with React server components or actions or anything. It's just the way the UI works. It's like, I think there will be a better separation of the React that's made for the UI, for the user to see, and the React that does the front-end processing, because as the times pass by, our front-end applications get more and more complex. And we are kind of taking that complex features of it and putting to our backend that renders our React. So we are taking there, we have the validation there, we have the actions there, we have the data creation there, the data fetching there, and then we leave for the client more of the things like, hey, show this or don't show this, and conditionals of rendering components. And the stuff that's more related to the UI, we still use the use effects, still use states to get those hooks. And there was another use case that we still had a use effect with the use from state, because we needed to show a toast, and this toast showed when the state changed. So we still need to have the use effect there. So it will not eliminate the need for other client component hooks, but it will eliminate some use cases of it, such as the data fetching, for example. We might not need it in the future. But yeah, that's it. It might not eliminate it all, but it will reduce some usage of it.
Great, thank you for the answer. And that's it. I don't see any more questions, so thank you guys for joining us for the Q&A session and for taking your time to educate our community. It was a pleasure to cooperate with both of you, and be ready that I will text you for the next React Global Summit as well.
Thanks for having us.
Thank you very much.
I mean, having me. Leonardo will say thank you for himself.
Thank you. Bye-bye.
Bye.
And yeah, let me invite our next speaker. We have 0 minutes left for a break, but it was a great pleasure to have a discussion and answer your questions. So please stay active in the chat. It's always a nice opportunity to have more clarity on the topic, to dive deeper. So I'm encouraging the audience to stay active in the chat. And yeah, we are ready to invite our next speaker, who is Ayush Tekur, community member of Wing Cloud, will tell us how to create a React app with Wing backend. He is live with us today. Hi, Ayush, how are you?
Hello, Sia. Hello. Am I audible to you?
We can hear you, and I'm so glad to be here.
Okay.
Please tell us something. What is the talk about?
Okay, sure. So I'm going to talk about how the developers can create a React app using Wing. And my majority of the talk will be based upon Wing, because obviously React, we all know what React is, a UI library, how you can create UI using React. So majority of the developers are aware of what React is, but majority of the developer community is not aware of what Wing is, what Wing backend is. So I'll keep my talk focused on that, how you can use Wing in your React, on your personal projects. You can get multiple projects using Wing and all that stuff.
Great, thank you. So please share your slides or screen, and we are ready to start.
Sure. Just give me a second. Okay. Okay, it should be visible now. Is it?
Yeah, please put the presenter's mode on, and I will add it to the stage.
Oh, okay. Okay, so I'm Ayush Thakur. Those who don't know me, I'm Ayush Thakur. Currently, by profession, I'm a developer advocate. been working as a developer advocate for around 4 years in this tech industry, and been working with multiple startups around the globe, worked with multiple technologies, React, JavaScript, TypeScript, GraphQL, APIs, some backend stuff also. And along with that, I'm a technical content creator. I do create technical content, write technical blogs, create technical video tutorials, guides, how to blogs, work on the documentation and all that thing. And I'm also a community manager. I do handle multiple communities, present on multiple social media channels that include Slack, Reddit, Discord, Hacker News, LinkedIn, Twitter, now X. And yeah, and these are my social media handles. You can follow me. You can ping me if you have any doubt, any query. So, okay, let's just get started. So, okay. So my talk will be how you can create a React app with Vim backend. If you focus on my talk title, there are main two topics, main two keywords. The first one is React, that we all know what is a React UI.js library that you can use to create multiple UI components, UI user interfaces for your websites and all that thing. And the second one is Vim, and majority of the developer community is not aware what Vim is. They haven't heard of what Vim is. They don't know what Vim is, what Vim can do. So my talk will be focused towards the Vim, how you can use Vim in your React app or any other framework. For example, Next, Remix, EtherJS, Astro, Angular, and all that thing. So okay, let's get started. So first of all, what is Vim? In a small nutshell, Vim is a world's first open source cloud programming language. Now, what is cloud programming language? I'll explain with the help of an example. For example, consider another language. I'll take an example, JavaScript. Okay, so you must have code in JavaScript. You must have used JavaScript in any of your projects. Okay, what do? You create a script.js file or any other .js file, write the JavaScript code, and define the functionalities, features, variables, functions that you want in your web app or any other application, right? So you write the JS code and compile it on your local device, not on online. You first compile it on your local device, on your machinery, debug it, found it if there's any error, make it more readable, make it more efficient. And once the final product is ready, you deploy it on the cloud service. Good. So Vim is just like any other programming language, but the main catch is Vim works on the cloud. Okay, so what is that? For example, you create a main.w, that is a Vim file, write the whole code, and before deploying it on the cloud service, you first try it on your local device, on your machinery, try out all the all the tests that you want to perform on your web application, on your application, debug it, code it, make it efficient, and all that thing. And once the whole code is ready, you deploy it on your cloud service. Okay. So the main thing is the languages like JavaScript or any other language, you first do it on your local device. Okay. What the difference between the normal language and the Vim is? You directly host on your cloud service. Okay. And what cloud service does it support? AWS, Azure, GCP, IBM Cloud Service, and all other cloud services that are present in the market. But the main catch is, why do we need Vim? Why do we need another programming language in this world, in this time where we have hundred or maybe thousands of programming languages already running in the market? Okay, we have JavaScript for web development, we have Swift for iOS, we have Python for machine learning, we have any other language for any other application, any other use case, correct? So why do we need Vim? Why do we need another programming language? So the thing is, Vim basically works on the cloud computation for the cloud applications. If you have worked or deployed any cloud application, you must have seen that there is a pattern. For example, if you want to create a cloud application, okay, so you have to write two different codes for the cloud application. The first one code is the application code that includes all the scripts, all the programs, all the components of all the functionalities, all the features that you want in your cloud application, correct? And that application code can be in any programming language, be it JavaScript, be it TypeScript, be it C++, Java, or any other programming language. Oh, cool. And the second one is the infrastructure code that basically works as that basically defines your whole cloud application's data structure. The infrastructure code involves the defining the cloud, defining the buckets, the queue, the stack, the whole data structure that you want in your cloud application. Okay, and the infrastructure code is mainly written in a Terraform application .tf extension. Okay, so in order to create any cloud application, you have to write two different codes on two different platforms, two different languages, and that becomes a major headache, major pain point for the developers, that they have to use two different languages to create a single cloud application. Okay, so this is the problem that majority of the cloud applications, cloud developers do face in their tech journey. And this is the problem that's being targeted, being solved. And what Wing does is it basically merges the two merges the two code that a cloud developer has to write. The first one being the application code, and the second one being the infrastructure code. So Wing merges these two models into a single Wing model and make it easy for the cloud developers to write the whole code in a single program, in a single model, despite of writing the whole code in two different models, two different languages. Okay, and here you can see a clear example of what difference does Wing makes. Okay, so if you create a cloud application without a Wing, you have to write, as I mentioned, you have to write two different codes. First one being the main.tf, the Terraform code that handles all the data structure, the stack, the queue, the APIs that you want in your code. Okay, and second one being the index.js or any other programming language code that defines all the functionalities, all the variables, all the features that you want in your code. Okay, and on the right hand side, you can see if you use Vim, how easy it becomes to write all this code in just hardly 2 to 3 lines. Okay, if you go with the without Vim, you have to write this whole code just to create a simple bucket and store a hello world simple string in that bucket. So you have to write this whole code just to perform this simple operation. And if you use with Wing, if you want to use Wing in your project, so you just have to write the import the cloud library from the Wing, create a bucket using that cloud library, and simply store the hello.text or any other string that you want to store in that bucket. So this is a major difference that Wings makes in comparison to the traditional method. And benefits, obviously, it being a normal programming language, you can develop and test it locally. Okay, and it comes with its own simulator to experiment with it. Okay, so what one of the main problem that cloud developers do is that they have to deploy their cloud application on a cloud service in order to test it, experiment it, play with it, debug it, and if there's any issue, any error, to solve it. Okay, so Wing comes with its own simulator, which gives a visual representation of your whole cloud application, that how it will work, how it will be deployed, how the user will interact with it. You can test it, experiment it using the simulator, and if you found any issue, any bug, you can solve it on the right time. Okay, and it is compatible with your stack. As I mentioned, you can use any framework, any programming language, be it JavaScript, TypeScript, C++, Java, or any other programming language with the Wing. It is fully compatible with it. It is fully customizable. Obviously, it being a normal programming language, it is fully customizable. You can customize it, and you can define the own functionalities in the Wing programming language that you want in your application, and it offers the cloud diversity. As I mentioned, Wing works on the cloud service. Okay, so on every cloud service that supports the work of that supports Terraform, every cloud service that supports Terraform, Wing will be compatible in all the cloud services. Currently, Wing is fully compatible with AWS, Azure, GCP, and Hybrid Cloud. And slowly and steadily, the team is working to make it much more compatible with all the other cloud services currently present in the market. Okay, so let's just before creating a React app, let's take a small demo of how Wing works. Okay, so I'll walk you through a small demo of how Wing works, how the simulator works. Okay, so let's just start it. So I'll open a VS Code. Okay, and let's just open a new folder that is an empty folder. Okay, cool. Okay, so I'll first create a Wing file. I'll name it main.w, main.w. Okay. W being the extension name for the Wing file. Okay. And so let's just create a normal bucket, a normal API, and a normal queue. Okay. Simple three things just created. First, I'll bring cloud library from the Wing directory, from the Wing part, and I'll use this cloud library to create a bucket, to create an APU, and to create a queue. Okay, so for that, you can simply define a variable API and new cloud.api, and that's it. Our API is created. Cloud library holds all the functionalities, all the features that API should have. You just have to fetch it and use it and create any other API queue or stack that you want to create in your part, in your application. Okay, so let's just create a bucket, and bucket is created, and let's just create a queue. Okay, so QUE, okay, cool, and cool. Okay, so our API bucket and queue is created. Okay, simple, no rocket science, and okay. So let's just run it and see how it works. So for example, for that, first is the console and use it, Wing run. Okay, Wing run being the command to run the whole simulator. Okay, so I'll hit enter and hopefully it should work. Okay, so it is deploying on main console. Okay, and here it is. Okay, you can simply see the API that we have created, the queue we have created, and the bucket we have created. And this whole is the Wing simulator that I was talking about, that I mentioned in the slide also. This is the whole big simulator that shows how your cloud application will be work, how your queue will work, how your API will work, how the endpoints present in the API will work, how your bucket will work. Okay, so let's just do one thing and try to create an endpoint on the API. And whenever that endpoint will be triggered, file will be created in the queue. Okay, so let's just do that. And API dot post. Okay, and I'll create an endpoint with the name in, and I'll use the infine method having a request parameter. And in that, I want file to be created. Okay, so in the queue. Okay, so for that, I'll use the queue and use the push method. And in that, I want to create a file with the name message pushed. Okay. Okay. And return the statement, return and a cloud return a response of okay, and it will return a status of 200. Okay, semicolon, semicolon, semicolon. Okay. Okay. Mm-hmm. What error it is showing? Okay, is there any semicolon missing? No, it is not. Okay, it should work. In cloud, okay, everything looks good. In reply side, 2.push, this is good. Cloud API response. Failed to allow, set it to 200. Okay, now it is good. Okay. So yeah. Now you can see our API when we click on ink, the post method is created, and when I click on send, the 200 status is showing that we have just mentioned here. Okay, so in that way, and when I click queue, go on queue, Okay, so our method is created. Okay, so and in the same way, for example, we can create a delete option. Also, we can create a other endpoints also to perform any other function, any other parameter on it, any other functional. For example, here we have used the queue to push a message on it to create a file on it, and you can simply create another endpoint to perform any other operation on it. And here we can create a counter also. For example, the cloud comes with a counter function also. We just have to use the cloud.counter as we have done in the initial things. And here, let's keep the initial value of the counter as 1. Okay. And I want whenever this whenever this endpoint is triggered, I want to increase the value of counter. So use the counter.inc function on the counter, and whenever and see our counter stated that has the initial value of 1. Okay, so whenever this endpoint is will be triggered and sent, and see the actual value has been increased, so our counter increase is working. And this is how you can use the whole simulator to interact with your cloud application, to run it, to test it, to debug it, to experiment with it, to play around with it, how your cloud application will behave when it will be deployed on the cloud service, how your cloud application will run when an actual user will interact with it, will play with it, will use your cloud application. And you can, based upon that, you can try out adding new functionalities, adding new, try creating new bucket, new queue, new APIs, and all that thing that depends on your creativity, of course. So that's how the Wing simulator works, and that's how the normal Wing file works. Okay. And okay, so this was the basically a simple demo of the Wing, and you can use. And now let's create an actual React app using Wing. Okay, so here what we'll do is we'll basically normally create a React app using White. Okay, and we'll create a Wing backend using the Wing file, and we'll connect Wing backend with the React app and fetch some data stored in the Wing backend and use and display it on the user interface of React app. Okay, let's just do that. I have already done it. Okay, so I'll show it to you. Okay, so it was React, not this one. It was React Wing. Cool. Okay, there you go. And you can simply see here. Let me just close it. Okay. Here you can simply see here I have just two directives, the backend and the client. The client holds all the normal JS, normal React app that you can simply create it using Byte or any other node modules. Okay, I normally created it. Okay, and the client holds the Wing file, and client holds all the Wing file. Here you can simply see. Let me just open it with you. Okay, input.js file, and here backend. Yes, here is the main.w file, and it is created in a similar way that I have just shown you. Here I have used two libraries, the Wing and the X. Okay, X because I want to create a reactor. That's why I have used X library. And here we have defined 3 parameters. First being the use build command, because we want to use the build command. So we have kept it to the project part, that is the client, because our actual project is the client. Okay, and the build command, that is npm run start. Okay, and here I have also created our API using the cloud.api that I just shown you. What happened? Okay, cool. So, so yeah, here we have created an API using cloud.api. Here we have kept the codes true. Okay, and whenever this file will run, React.add environment, this will add this key and this value pair into the environment variable so that it is available to the whole project and we can fetch it easily. Okay, and here we have created a single endpoint on the API, that is a slash title using inflight, and it will return a status of 200 along with the body that holds the string hello from the API. Okay, so this one is the whole backend, the whole Wing backend, and this is already connected to our React app. Let me just show it to you. Okay, so you can see here, this is the normal usage. hook that we are using, and there is the function that is the fetching data from the Wing backend. Here we are simply assign a get title, a normal async function for having the response variable. This is fetching the data from this API URL that will be deployed when we'll run the Wing backend. Okay, it will fetch the title, that is the body, that is the hello from the API string. That it will fetch the title from that Wing backend, store the title in the set title method, and give it to us. Okay, so let me just show it to you how it will work. For that, first we have to run the Wing backend, and after that we will run the client app. For that, we'll use the Wing backend / main ww, because our main ww resides in the backend directory. Simple. So we'll run it, and hopefully it should run. And see, okay, cool. See, our React app is created that holds the website, and that holds an endpoint. And our API is also created that holds an endpoint. Cool. So our backend is working perfectly. And let's open another terminal. And here I'll run the client directory. First, I'll go to the client using cd client and using npm run start, that is a build command. Okay. And it should work. Yes. For a fraction of a second, you will see the default value, and after that, you will see the hello from the API. And see, first, for a fraction of a second, there was a default value because at that time it was fetching the data from the backend. And after the data is successfully fetched, the title is successfully fetched, it is showing the hello from the API string. Let me do it again. If you have missed it, let me do it again for you. Okay. So I close the terminal. Okay, and run it for you again. npm run start. Okay. For a fraction of a second, there will be a default value, and after that, there will be hello from the API. The default value and hello from the API. Okay, and that's how you can simply create a React app using Wing backend. And this was just a very basic, very normal example of very basic example of what you can do using Wing. You can use your own creativity. You can use your own curiosity. You can use multiple sources available online to run your creativity, to run your mind, to run your ideas, and create as much as projects using Wing, using React, or any other framework as depending upon your requirement, depending upon your needs. And that's how Wing works. Okay. And you can simply go to this repository, just scan this QR code. Let me represent it for you. You can simply go to this repository or scan this QR code. Here, the whole process of how you can create a React app that I just shown you, how you can create that similar React app in your local device. The whole process of that is shown in this repository, in this QR code. You simply have to just scan it, and it will redirect you to that GitHub repository. Okay. And thank you so much. And this was me, Ayush Thakur. You can simply scan this QR code. It will have a link tree that holds my own all social media handles, be it Twitter, LinkedIn, Slack, Reddit, or Discord, or any other social media handle. And you can simply ping me, connect with me. I'll be much more happy to add any value in your tech journey to help you out, to guide you out, and mentor you, because that's what I'm doing in my whole tech journey. I love doing that. So thank you so much. And before ending it, you can simply go to winglet.io. That is the official website of the project of the Wing. You can simply go to it. You can simply use the read the documentation. They have their own online ID also. That is the playground. You can simply go to playground, and here you can try out creating Wing projects, creating Wing code. You can simply try it out, run with it. The whole simulator will showcase it like this. So yeah, thank you so much. Thank you so much.
Thank you, Ayush, for the presentation. It was really nice. Thank you for taking your time for educating us. Thank you.
Thank you so much. Hope you will like it. Thank you.
Of course, thank you. And it's time to invite our next speaker, who is Gurmeet Singh. He is a software development engineer at Swiggy, and his topic is enhancing the React testing with Jest. He is live with us today, and let me add him to the stage. Hi, Gurmeet. How are you?
Hi, Zia. Fine. What about you?
Also fine. Glad to see you here. So tell us something about your presentation. What should we expect?
Hi.
Can you hear me?
I think there's a network issue, right?
Oh, you were out of the stream for a moment. Could you please repeat?
Yes. Hi. Hi, Zia. How are you?
Great, great. Tell us something about your presentation. What should we expect?
We can expect like we will be able to understand the unit testing with React, like how to perform unit testing, how to make our code safer, secure, and the code which can go to production. Like that will be our goal today.
Great. Thank you for giving us an introduction, and I'm adding your slides to the stage. So you can start. Thank you.
Okay. Yes. So hi. So today the topic will be React testing with Zest and React testing library, RTL means. So let me tell about myself. So myself is software development engineer at Swiggy. So there I completed my internship. So there I work with React.js, TypeScript in frontend, and Golang and Spring Boot for backend. And also I worked as software development engineer at IND Money, where I work with Next.js and TypeScript. So that's all about me. So let's go ahead. So the agenda of this speech will be we will discuss like what is React testing library and what is Zest, and how we perform the unit testing using React testing library, and how Zest will help us to run the tests. Next is we will perform a code demo like on the VS Code. So there's a small code demo that you will be able to know like how to run the test and how to write the test and how to maintain the files, test file like that. So then we understand like how to create a test suits, mocking, interaction events like click over, how to test them. Also, we will understand some of the RTL queries which are very important. So whenever you write the React.js file, so there you need to test the component. So these are one of the important uh, DOM functions which we will use. So let's start. So firstly, what is RTL? So RTL means the React testing library. So it is a JavaScript utility that provides a virtual DOM. So in simple words, like whenever we create a React file, .js file, a component.js file, a header.js file, so we create set of components. So that is a DOM. So RTL provides us a virtual DOM that is available. Now it provides a virtual DOM. Why? Because we need to test the components. So it's the RTL responsibility to provide the component, and we will test upon that. Now let's understand what is Zest. These two are main things for running the test. So like Zest is a JavaScript testing framework. It finds a test, run the test, and find how many tests are passed, test suit passed or failed, like that. So let's go ahead. Now we will have some demo of unit tests using Zest and RTL. So let's see if you're able to see the screen. Present, share screen. So is my screen visible? Yes. Okay. So like for example, I have created a React project. So in this React project, I have created a component text1. Now first we create the component like we have a div, simple div within which we have the h1 Gurmeet. Now we need to write the test for this. So firstly, we will create the test file here, text1.test.js. Generally, we create the test file separately, but we have created here only. So now if we go to text1.test.js, so firstly, like whichever component we need to test, firstly, we need the component. First, it should render. Then we pick those component and test upon that. So first we render the component. Let's say test name is, we can create any test name, but test name should be readable so that like we have to create many cases. So that's why test should be readable so that other person can also understand like for which purpose this test is written for. Now, firstly, we render the text component, and after rendering, we will query upon the component. Like for example, text is Gurmeet. So we will say like screen dot query by text. Like we query by text like Gurmeet, and we store it as text element. Now we got this text element. firstly we render the component, then we got this text element. Now we check whether this text or element is in the document. Yes, it is in the document. So this test should pass. So let's run this test. So if I write like this, npm run test text1 dot test.js. So if we run this, let's see, like it should pass. Yeah, so the test is passing completely, like Gurmeet text renders correctly. That's why, like if I read many tests, so many tests will come, so it will show tick and cross accordingly. So that's why test name should be meaningful. So this is a small demo of how the test works, like how we write the unit test. So let's go to the slide back again. Yes. So now we understand like how to group the tests. So we generally study test suite. Each test suite has many tests. So similarly, we group the test. So this is a way, this is a basic syntax. Like here's a describe, and which is a test suite. We should give the proper name here as well. And within which we have two tests. We can create as many tests as possible and separate them. For example, if we have a home page, it has navbar, footer, sidebar, like these. So we need to write the test for each. Like header has icon, header has like home, navigation, like all these. So we need to group the test accordingly. So let's understand like how we group the test on the VS Code only. It will get better give us idea. So let's jump to the my screen. Let me try to jump. Stop screen, share screen, entire screen. Yes, my screen is visible now. So like if we go to the, so we have this text dot component we have done. Now let's jump to the text.js component. So right, so here, like let's move this. Yes, so here I am going to create the group of the components, like group of the test. So for example, we have a div here again, we have a h1, and we have a button name is click me, let's say, like random text. Now the main idea is we need to check like how we create the group of the test, like how we create the test suite. So firstly, similarly, we using the describe, we create the group, like this is the test suite. Now within which we have the two tests, one test and second test. Now first test is like we need to check whether this like Gurmeet is coming. So how we check like Gurmeet text renders correctly. Now within this text test, we will render this text component. First we render. So always we need to first render, because if we not render, then how can we access a DOM? So first we render this text component. Now after rendering, we will find screen.query by text. Now we query here by text. So here is a Gurmeet. So after querying by text, this is a text element. We got this text element. Now we check that is the text element is in the document. Like it's a basic test, but we write more complex tests whenever we create the click events, like all these. Now similarly, if we want to create the test for button, so like we write the test button shows correctly. So like click me button shows correctly, anything. So we render this text component again. After rendering, we have the text component. Now we need to find here like whether the button is present or not. So like generally for the button text components, like all these basic HTML components which are provided by HTML, we generally use a get by role, paragraph, heading, these all things are provided by HTML. So we write get by role. So get by role is button. So we get by role. So there is only one button. So if, for example, if we have many buttons, so only first button will be returned here. Okay. Now after that we have button element. Now after getting the button element, we expect that this button element is in the document. So this is a group of tests. Now we will see like how this will be shown while running the test. So let's write this npm run test text.test.js. So let's write it. Let's see how it runs. So there's a test suite test. Let's see. Yes. So test suite is one. This is a one test suite. This is a one test suite within which we have two tests. So both are passed. So here first is passed and second is passed. So this is how we group the test. So let's jump to the slide again. Yes. So now we have done get by, query by, find by. So whenever we want to, for example, we have many buttons in the component, like text component is button click me, submit, update. So for getting these, many times we want to get all the buttons. So for that case, we use get all by. We use query by, query all by, find by, find all by. So we will discuss like query by, find by, how these are different. So we will understand in later, right? So let's jump to the next slide. So let's understand some of the functions that we have discussed now. So for example, this is a div. You can see like label HTML for name. This is a label we have given to the input. Now we want to get this text box input. Input type is equals to text, ID is equals to name. Now, if we want to get this text box, so we will say const name element is equals to screen dot get by role. Like this is a text box, so we will say this is a role. Like heading is a role, paragraph is a role. So get by role. So we will say get by role text box. We got this text box, and after getting this text box, we check whether this is in the document or not. So this is a way like we get by role. Similarly, we have many DOM function. We are going to discuss them one by one. Most important one we are going to discuss here. Next, come to the get by label text. Get by label text is, for example, this is a label HTML for name label. So now we want to get this label. So we say like screen dot get by label text. So this is a label text name. So we get this label text, and this is a name element we got. We cache this name element, and we say like whether this name element is in the document dot to be in the document. Like this is a function to check whether it is in the document or not, right? So let's go to the next. Next is a get by placeholder text. So we have done two things like get by role, get by label text, get by placeholder text. Like if you see there are many, but the most important one we will discuss, like we need to check whether the placeholder is coming or not. So we will say like const name element screen dot get by placeholder text. So for example, this full name is not present, so it will return null. So it will not be in the document, so this test will not pass. So we need to check whether test will pass or fail. So this is a placeholder full name. We get this placeholder text and we check whether it is in the document or not, right? Next, come to the get by text. So get by text is, for example, we have paragraph, I am taking the session. Now we need to check whether in the DOM, like whether in the screen, it is in the present or not. So I am taking the session. Let's get by text. So we got the paragraph element. So if there are many paragraph element, first one will be returned. So paragraph element comes, we say expect paragraph element to be in the document. So this paragraph element will be in the document, right? Next. So we have next thing is get by display value. So get by display value is, for example, we have input text box, and within this, like for example, we have input text box, and within this I write Gurmeet. So this is a display value. Gurmeet is a display value within the input text box. Now we need to check whether this display value is present or not. So we will say screen dot get by display value. So we get by like Gurmeet is present in the display value. Yes, it is present. So we check whether it is in the document or not. Simple. Now similarly, we have other like get by all text. So generally within the image, we generally prefer to give all text, and it's good to give all text because if the image is not present, so it gives us basic idea of whether the image is like what is the image kind of. So how to test this? We check like screen dot get by all text. So my image, like this is all text, so we get by all text and we check whether it is in the document or not. Similarly, we have the get by title. So we have the span tag. Span tag, we give the title. Let's say I am the span. This is the inline element. So I am the span. So this is a title for the span. So we'll say like screen dot get by title. This is the title. So I am the span. If this is the title is present, so it expects it will be in the document, right? Now similarly, test ID. So data test ID is generally used. So we get by class name, get by ID. These are all other things. We also use test ID. So this test ID is the most common way. So whenever I also work at Swiggy, so I created the test ID. So test ID is a easy way, like we can share the test ID between both the files. So we write, let's say text element. This is a test ID. So we check whether this test ID is present in the document. Like this is a way, like whether this like gourmet text is rendering or not. So to check whether this gourmet text is rendering, we can just check whether this data test ID is present. If this data test ID is present, then obviously the gourmet text is rendering. Otherwise, there is some conditional case which is not allowing to display it in the document, right? Next come to now query by and query all by. Now, so like we have discussed these many. So for example, get by role, get by label text, get by placeholder text, get by display value, get by all text, get by del, get by SID. So from these we can get the idea, like we are just trying to like get the control of the component. Like we want to get this header tag, we want to get this paragraph tag, and we want to test it whether it is in the document or not. Not only in the document, we will discuss ahead now how we will, like for example, we take the button. After taking the button, we check, we generally click on the button. So we check whether like its state is changing, or whether on clicking the button, the header component is coming or not, whether the sidebar is coming or not. So this is the way we generally use to test the components. So like we have done these many get by role, get by label text. So same for query by and find by. Query by and find by also give the same, like get by role, find by role, query by role, query by label text, query by placeholder text, query by text, query by display value. Now we have query all by also, which gives the array. Similarly, find all by also, which will also give us the array. So these all are the DOM functions which are available with us, which will help us obviously in testing the component. Now we will check like what is query by and what is query all by and what is get by, get all by. So generally whenever we write query by and query all by, and let's say if error comes in between, let's say test doesn't pass, so it gives us the whole set of DOM tree, which will give the complete description, like which element is coming and which element is not coming and what we have added extra. So it gives a descriptive error whenever the element is not found. So for example, how we do query by text, similar to get by text, like text element screen dot query by text Gurmeet, we expect text element dot to be in the document. So this is the way that we query by text. So same, it's completely same, right? Next is find by and find all by. Now what is find by and find all by? Find by and find all by returns a promise. Like wait, yes. So it returns a promise which is resolved when an element is found. For example, let's say we call some API, right? And we are waiting for its response. So generally what we use, it will return as a promise. We use async await to make it asynchronous, synchronous, right? So we will, so similarly we do here, find by and find all by return as a promise. And generally the default timer set is 1000 millisecond. So we can set the default timer, let's wait for 1200 millisecond, 2000 millisecond. It's up to us, like how much we want to wait based on the API, right? So we can use a async await. Since we are using promises, obviously we use async await. So for example, wait, yes. So we have cons click me button, await screen dot find by role button, name click me. So like we find by role, as we already discussed, like for getting the HTML HTML tag, we use a find by role. So button role will be find out. So after finding out, like there can be various button. So we need to find which button, like click me, submit, update. So here we say name click me, like send me the click me button. Okay, so we expect that this is in the document. So the difference between query by, get by, and query by, query all by, and find all by using promises. It is running promises. Whereas query by and query all by is giving the descriptive error whenever the element is not found. And its main idea is to check whether the element are not present at DOM. It is used to prove like element is not present at DOM, right? Whereas get by is the idea is we need to get the element in the DOM. We need to check if the element is present in the DOM or not. We first get the element. If it is not present, dot expect dot to be in the document, to not be in the document, like anything, right? So like we have find by, find all by, as we've discussed. Now let's talk about interactions. Like many times we do the interactions, like for example we do the click events, and for example we click the button, we hover the button. So so like for example we have a button in the for example home page, and we want to first we render this button. So next we want to click the button or we hover the button, and based on that some action is performed. So there are some set of testing library providers some set of events like user event. Not only user event, there is also fire event. Fire event also fire event dot click this button, fire event dot hover this, like that. So these are the set of interaction events. So let's discuss about them on the VS Code only. So let me share my screen, share screen, share entire screen. Yeah. So yes. So as we have created a button, click me. So similarly, we can create a various button like button submit. Like we will create like on click button, on click is equal to, let's say we need to console.log. Let's create the functions on the const handle click console.log and like similarly we have handle submit const handle submit. So we have console.log I am submitted. Yeah. So now whenever we click, so we will call a function called handle click. Like this is a basic React.js I'm using, right? Similarly, whenever we submit, we use on click handle submit, right? So these are the two buttons I have created. Now we are going to test them. So let's create the test. So let's create the test within this group only. Let's create the test. So we will have test. We will say button is clicked, right? Let's say. So firstly, what is a thing? First, we want to render this text component. So let's render this text component. Now after rendering this text component, we need to get the control of this button. So we will say const button element, like we can say click button element, click button element, click button element is equal to screen dot get by role. Yes. So get by text also we can use get by text. So we have click me, right? Now what is our idea? Yes, we are going to like we have used get all by text. So instead of this, we can use a button. So it will give us the array of buttons. Give me some time. Like this should be button. Yes, yes. So this is a button. So it will give us array of like for example, let me right click button elements here. So array of click me, submit. These two comes into this button elements array. Now what we want, we need to click the first button. So we will say fire event dot click button element of 0, right? So first button element we want to click. So let's import the fire event. Like if the fire event is not present, let's use a user event only. Import user event. Yes. So we will use a user event dot click. So in this way, we will click the button. Let's say on clicking the button, this, for example, on clicking the button, let's maintain a state const visible set visible is equal to use state, and let's say it's false correctly. And on clicking the button handle click, we make the set visible as true, right? It's a boolean. Let's make it false simply. Yes. So we make the set visible as true. Now, whenever the visible is true, we want to render a heading tag. Hi, I am happy. Yes. So we on visible. Yes, on visible as true. So we are representing a heading tag like hi, I am happy. So now we click the button. Now after clicking the button, what we want to check whether this heading tag is visible or not. So let's add some data test ID here. Data test ID, like data test ID, or we can give the text only, right? So we will say const heading text is equal to screen dot get by text, and let's copy this. I am happy. Or we can use a paragraph tag if we want, and we can use a get by rule, and within the rule we can pass a paragraph, right? Now we say that expect heading text dot to be in the document. Like this is the way. So what we have done, we have rendered the text component. After rendering the text component, we have taken out this button element. Button element we have taken out. And after taking out this button element, what we have done, we have clicked this button. After clicking this button, we check like we get by role. Like this should be visible now because on clicking on handle click, set visible is made as true. So whenever visible is true, this should come in DOM like hi, I am happy. So we will say like get this it should be paragraph text right there. Paragraph text, right? So paragraph text, yes. So we will say expect this paragraph tag to be in the document. Similarly, for example, if we want to write for this, so what we need to do, similar thing like button is like, for example, let's say we create the hover on touch move, like we can do anything on touch move. Yes, let's do this. So where we say like button is hover. Let's see, right? Let's create anything. So in this, similarly, we do render the text. After rendering the text, we get this button element, like button elements. So we want to get this second button element. So button elements is equal to screen dot get by all text, and then we get this button. After getting this button, we'll say user event dot click button elements of 1, right? Now after there is some spelling mistake, yeah. So we got the second button element, and after getting the second button element, we will say like let's do the user event dot click. Yes. Now what we want, for example, we again click this. So we have clicked this, or we can hover this, like as like there is a hover property as well in the button element. So similarly, we get the DOM. We hover upon this. Based on that, we perform the action. We check whether this test pass or fail. If it doesn't pass, let's fix it. So this is a way to test the components. So let's jump to the slide again. Yeah. So like we have the fire event as well, we have the user event as well. There can be many testing library. So these two library I have used mostly. So we get by role, click, hover, or all the actions like perform, on mouse hover, on mouse enter, on mouse leave. These all actions we perform will be done here, right? So let's go to the mocking. So now, what is mocking? So many times this happens. For example, let's say material UI. So generally we use a material UI in the React to save our time, to not make the components again and again. For example, we create the cards, just put it from the material UI, create the table, put it from the material UI. It has very good design, and like all the components are already created. So we don't need to create them again and again, just use them. But yes, it makes the file somewhat heavy, but fine. So like these are already tested. So whenever we are testing our components, we don't need to test those material UI. For example, if we, let me come to the screen again. Let's come to the screen, present, share screen, entire screen share. Yeah. So I think screen is visible. Yes. So for example, many times, like for example, this is a heading tag, this is a table, let's say, and within this table, like we are not creating this table, and we have used some React material UI table. Consider like we have imported already. So React material UI table, we, for example, here is a React material UI. So whenever we go React material UI table, so whenever we go, for example, React table component, and for example, we have taken this data grid and we have pasted in our code. Let's take this data grid and paste in our code. So like this is already tested by material UI. Why we need to test that? So like we import something, like for example, import data grid from something dot slash material UI. Like let's say this is a correct import. Now we have this data grid. We have added this data grid. We don't need to test this. So how can we prevent this to test? Because obviously if we test this whole component, we should test this, right? But why we need to test this? If this is already provided by material UI, this is already tested, we just need to use this. We don't need to test it. So how can we prevent it from being tested? So we generally use a mocks. So mocks are of two types, like we use for functions, we use for components. Like functions, like for example, this handle submit. It doesn't matter like to me like what handle submit works. Matters to me is like whether this handle submit function is called or not, whether this handle click function is called or not. So this is the mock function. Similarly, matters to me is whether this data grid component is rendering or not. So whenever such kind of things comes into our mind, we generally use a mocks. So we mock this function. So creating the mocks is very easy. So just we have the Zest provides a mocking thing. For example, cons, let's say I have created a hello function, like let's say handle click mock is equals to Zest dot function. So Zest provides us the mock function. So this is a way, like let me come to the slide. Yeah. So yes, so this is a Zest dot function. So mock one, mock two. So we can create many mocks here, and just we don't need to check whether many times we need to check whether this function is calling or not. So we just need to mock this function, like handle click mock this handle submit. Just check whether this is calling or not. Inner functionality doesn't matter to me. That is the idea between Zest, that is the idea for mocking the functions. Similarly, whenever we want to mock the components, so similar idea will be added for mock components. So let me come to the slide again. For example here. So for example, we want to mock the header component. So first we write its path, zest.mock, like header. Let me make it full screen for now. Right. Yes. So we mock this header dot slash header. After writing this, like whatever ES module true, what we want to return, like this is the way we mock the components as well. So this is how we mock the components. This is how we mock the like functions. So this is not the end of the React testing. React testing provides us various set of libraries, testing libraries, DOM functions, and we somewhere use spy on. Like if I go to the Google and if I check the React testing with Zest, so let's come here. Yes. Yes. So this is a, like for test, we generally use it as well. So instead of test, we can write it as well. So changes, like this is a test component. We get the component. Let's render this component. Then we check to JSON, then act upon it. So this is not the end. Like as you explore more and more, so you will get more deep dive into the React testing. And like for example, this is a component. So here is a state, here is a function like this. So if we want to, like, why this is cleanup? So this is also one thing, like before each, after each cleanup. Many time it happens when we run one test and when we go to second test. So previously rendered component comes two times. For example, I have rendered heading one. Next, again, I run the test. Again, I'm rendering. So it comes two times. So after each test, we want to clean up the first test in the test suite, then run the second test. So generally we use cleanup for cleaning up the DOM, right? For that purpose, right? So that is a thing. So here is a fire event.click get by label text. Then expect this to be true. Like these all things are available in the React testing library. So that's all from my side. This is how unit testing work in React.js.
Thank you, Gurmeet, for the presentation. It was really interesting. And yes, here's the Q&A session.
Thank you.
And now it's time to introduce our next speaker, who is Deepa Subramanian. I hope I got her surname right. She is a founder of Viva Solutions, a good friend of ours. She was presenting for React community at Geekle multiple times, and I'm so excited for her presentation. And she will tell us about building scalable UIs with component-driven micro frontends. Welcome to the stage.
Hello, hello. Good morning, good afternoon, good evening from wherever you're joining us. Welcome to Geekle React Summit. Thank you, Geekle, for giving me this opportunity. And this has been a few years now that I've been presenting here. Thank you so much for having me here. Today I'll be talking about building scalable UIs with component-driven micro frontends, right? So let's see what are the different architectural approaches that are there for building frontend. So that's the whole idea about this talk, right? Myself, my name is Deepa. I am the founder of Weba Solutions, and I'm also a Google developer expert in web technologies. And here is a LinkedIn QR code. And also note that every slide will have my LinkedIn handle at the top right. So fun fact about me is I love coffee, and especially a South Indian coffee. Just to begin with, we all know there are different, oh, by the way, I just wanted to make sure that this talk is not for somebody who's a beginner. You should have built a web application before you know what are these types that I'm going to talk about. At least be familiar with it, right? It's not for beginners. So, or it is not for somebody who does not know anything about front-end technologies at all. So just to set the stage here, there are some of the common types of web applications that you might know. To begin with, we have single-page application, we have multi-page, and we also have progressive web applications. I did a lot of talk on progressive web applications. If you want, you can check out online. And then there is dynamic application, animated applications, static pages that you can create. You can create pages using content management services that are available, like Contentful and things like that. And there's an e-commerce application too. So there are different varieties, but I just picked the common ones, right? So having said this, because there are different types, it is very, very hard to do front-end development, right? It's really hard. Why is it hard, right? First off, to begin with, let's talk about why is it hard, right? What makes it harder? To begin with, let's talk about scalable UI. What is it, right? What is scalable UI? And, scalable UIs are nothing but that which adapts to an application that adapts to all screens and site resolutions. So when you say that you built a picture perfect application that can be rendered on all sizes of screens, then you built a scalable UI, right? Does it really matter to you, right? Why is it important to build scalable UI, right? You know it is very important because you can reach a wider audience. It improves your user experience. And 3, you can also make sure that when you do scalable applications, you have reduced maintenance as well of your application. So that's why it really matters. The question is now, is it possible to build a scalable UI, right? So if you're wondering, the answer is yes. You can build scalable UI using several techniques, such as responsive web design, and then building with reusable components, which we'll be touching upon in this session towards the end of this session. So yes, it is possible to build scalable UI, right? The next question comes to you is, how do you know? For those of you who don't know, a ruler is also called a scale. That's how we used to call it back home in schools. So people who are from India, they would know when I talk about scale, it's a ruler, right? So how do you know that you build a scalable UI, right? So the question is, how do you know it, right? When you build an application that is scalable, you build them well based on these 3 things. Your application is magically, smoothly performing. And it's always, your application is always available. There's no downtime at all, for sure, right? When you deploy something, and imagine I'm talking about a large company. You're working in a 20,000 or 30,000 people company, right? That are distributed globally. And you start deploying in one of the regions, and it's available, and then the incremental upgrades of your application is also available in other parts of the world seamlessly. So again, if you can maintain your application easily, those are the things that would, these are the basic principles when you say that you have built a scalable application, okay? Now, things happen. Life does not go the way as we plan, right? Most of the times it does happen. We do have issues when you try to deploy them. All of a sudden you did a code merge, and then boom, something is broken. So things happen in life, right? And then as a front-end developer, you need to know that's when architecting your front end comes into play. There are several ways to do it. We'll start talking about it in a moment, but understand that there are different ways to architect your front end application, right? To begin with, back in the days, I'm talking about 20 years back, if you have thought about it, people had only monolithic architecture. That means that you had UI, your backend, your logic, all in one box, right? So nowadays, versus, this is a pretty history lesson. So microservices architecture, this is very popular today's, it's very popular these days. It's an architectural method that relies on a series of independent deployable services. When I'm talking about, if you see here, monolith was together, all these things together, but then the business and the logic was separated as a microservices at the back end, right? So each and every specific service would do only one thing. So we still have the whole UI left out here. So that's one of the things. And for just switching gears, let's talk about front-end architecture. There are different ways to architect your front-end. So we'll start off with monolith now, and then we'll talk about the rest. So to begin with, we all start our application like this, right? A monolith architecture, like I said, your UI, logic, and data, all of them are tightly coupled, and you have to deploy them together, and it's all maintained in one code base, or one repo for that matter, if you're using a GitHub. That's how it is. And imagine we begin our application like this. You start your React application, it as a monolith, and it gets to, it starts to become popular. And someday, overnight, it grew, and your app exploded with users you cannot handle, that your application cannot handle, and boom, your application becomes unavailable, right? When there is an app explosion happen, your application was not able to handle it. So this is a scenario that might happen. So when it happens, what are the challenges, right? You know that you did not build it for scalability, one. And the maintenance of it starts to get little shaky, right? So and then as and when your code grew, your teams also grew, because it's a growth is a good thing, right? Your application is being used by many people, so it's a good thing. Having said that, it's a good thing also, but at the same time, and so many people, when your team grows, you don't know who is owning what, right? And then every time you add a new feature, you keep shipping new code all the time. There's a cost involved to it. Then it becomes a maintenance issue. It becomes a hell of situation, right? So that's what happens with monolith architecture. Now let's move on to the next one, which is a modular monolith, right? So let's talk about modular monolith. Here, if you see this very clearly, see this, there's UIs everywhere, and there's a couple of libraries. And note that we are just talking only about the front end. So what is a modular monolith architecture? Here, it consists of mainly loosely coupled modules. Modules represent cohesive set of functionalities. Modules are also independent of each other. For example, you have bookings, you have payments, you have notifications and shipping, etc. You could have it as many modules as you want, and then each of them are independent of each other. So and they can all interact with the database, right? That's how you could architect your application. Here is an example. If you see the source code and you have feature inside the features, you have authentication feature, product catalog, and then shipping cart, right? So imagine you are using React and you have a reusable component for login. And then these are, you have features directly inside of each of these directory. And also note that there is a shared directory which can have styling or some kind of components that you can share with these features, right? So what does modular monolith do for you, right? It has you can reuse code, and you can deploy independently, and you can also say that, hey, team A, you are responsible for product catalog. So you're responsible for it. You code it, you ship it. And then the thing is, you have a clear separation of who owns what, right? That's what modular monolith contain. This is one of the things. And I had a slide which also says that. Okay, yeah, that's all about modular monolith. Now let's move on to the next one, which is very famous also. That's called as monorepos, or also called as integrated application, where you see these applications are all separately built, right? We'll just talk about it in a minute. So a single repository, mono is single, right? And then repo is repository. That's why I gave it as a separate wording title. But in general, they are put together. So here, just for your understandability, a single repository containing multiple distinct projects with well-defined relationships. See, for example, you have an app 1, app 2, right? And this is very beneficial for large applications. Again, I'm talking about enterprise scale applications. And then the previous company that I used to work with, we had a suite of applications. And then there are times that we have to, there are some applications, though we all built it in separate, our own apps, still it all gets combined as one single thing as well, project as well. So what happens is it has, enhanced code sharing and reuse, simplified dependency management, improved collaboration, and you can streamline testing and CI/CD pipeline too. So this is an example. So monolithic repository or monorepos is a strategy where the code from different multiple projects. See, app 1, this is if you're thinking that there's a project, multiple projects inside that, within a single version control. Like I said, you merge it together, and then everything, when you push the code, it goes from one single repository too. So also note that here it can also have a shared components too. So some of the, if you see, I know the companies like Google, Meta, Airbnb, they all use monorepos. This, I found it out in the latest article from Byte2Byte. I don't know whether you read those articles, they are really, really good. If you are not somebody who's not familiar with it, go check it out. It's really useful. So these are the companies that use monorepos, right? Now, this is the next part of our talk, the main one. We are going to be talking about microfrontend, sorry. As you can see, as we started talking about this whole architecture, if you see at the top, it says independently deployable. When we say it was tightly coupled here, the more you go towards the right, the more decoupled your code will be, and more easily or independently you can deploy your application as well. So that's why those blue arrows are there. Now let's move on to microfrontends, right? Most people disagree with microfrontends are microservices for frontend, right? This, I would also agree with that, because microservices primarily is all about backend and backend functionality. So a service could be one specific service could be handling only one functionality, right? So when we talk about microfrontends, it differs basically with the granularity, right? When I'm saying granularity, it could be like a large feature or a specific functionality based area. So you cannot say that microservices are equivalent to microfrontends. And same with the complexity. It adds a lot of complexity when you are trying to create microfrontends for your front-end development and deployment. And same with focus, when you are trying to approach this using microfrontend architecture, the focus is on reusability and composability, right? So understand that microfrontends are a small self-contained part of web applications user interface that can be developed and deployed independently. Why use microfrontends, right? To begin with, microfrontends are technology agnostic. You can implement it with different tools and frameworks such as React, Vue, Angular, Webpack, etc. So let's see how it differs on a high level. If I show you the project folder structure, you might understand much better. So here, if you see, there's something called as a host application. And then there are two, you have a directory with microfrontends, and then there are two microfrontend folders here. And then you also have the shared one, right? So the host application here, what it does, it acts as a container or shell, renders the microfrontends in their designated area. For example, you're creating an authentication one, and in the microfrontend 2, you're creating a product list, right? So when you try to deploy it, what this host or the shell would do is it will render those unappropriate areas of your application, right? It might manage overall navigation, user authentication, and layout correctly. So here, each subdirectory, like this one, like I said, microfrontend 1 and 2, with its own code base, has its own code base. It could have its own React components, styles, and logics, but the styles can come from the shared folder too, right? So understand that you are separating out based on specific UI. So what are other benefits of using microfrontends? They are independently deployed and tested. So that way it becomes easier. And then it's an iterative approach. Like I know you as a team, imagine you have a globally distributed team. And then one team wants to deploy and migrate their code. Boom, this can be done, right? They can have their own release cycles and maintenance. They just have to maintain their part of the code. And it also allows to make, it also gives autonomy for teams to make technical decisions. So at the end, you also build an application that is built to scale, right? So I talked about team autonomy. That what does it mean here, right? What exactly when I say that team autonomy is? So you create a micro front end. You have a team that is micro front end, A team, and then B team and C team, right? These all use different tools, like I said. You can all use different tools, but then when you compile it together, when you deploy it together, this is where the shell comes into play. That's something when they put it together, that's called as UI composition, right? That happens here. And before we talk about what exactly, every micro front end should have at least these essential parts, right? One is the container that we talked about. This is the one that mainly integrates and orchestrates your micro front ends, the shell that we talked about. Then next comes the integration layer, where it's a mechanism of integrating micro front ends into the container application. That is the host one that I showed you before. And then you have routing. It determines which micro front end to render based on your user navigation or the URL. And you also have routing, right? Communication is the one that I think I messed up. The other one was the routing. The communication is the one that allows you to communicate with each other or with the container application. So how do you share? Like the host application, imagine that project folder, or I can go back to it, the end of it. So how does the communication share between the micro front end 1 and 2, right? And then routing again. And then we talked about styling. It could come from the shared folder, right? And then CI/CD, how do you want to test? It enables you to, independently test and deploy micro front ends. These are some of the things that you should have figured out, or sit with your entire team and talk about it. And then finally, who owns what? Versioning and dependency management, right? When you push the code, who is pushing, this version of it, or, those things have to be also a part of when you are planning out to have a micro front end architecture. So these are some of the musts that you need to have when you're building your micro front ends out. So there are different approaches to this. When I talk about different approaches, we have, I'm going to be talking about component-driven here, but understand that there's something called a module federation, which is popular, web components, iframe, and then edge-side composition, etc. I'm not going to be talking about it, but these are different approaches that people have used before. And today we'll be talking about component-driven. So before we go to that, integration approaches, right? So when you are trying to integrate, imagine this slider, right? If on one side of the slider, the application is less separate, and then have, it is mainly monolith. So you just have, but it's easier to set up and maintain. As and when you're trying to use this approach towards the right side of the spectrum, your application ends up with bigger setup and complexity, and there's a maintenance cost. But having said that, a lot of companies use that, and still they get the benefits out of architecting their front end using micro front ends. We'll talk about who are the people that are using. So before we move on to the next thing, let's talk about some component-driven approach, right? Here is a component-driven approach. If you see, this could be a monorepo to see, because it says app A, app B, and then you can either have it as a component-driven approach. If you're approaching, you can use monorepo or as micro front ends too. Depends on how you architect your application. So you could, if you're using React, you can use it with Material UI and React Bootstrap or and Design, something like that. So what makes it happen when you're when you're using component-driven approach, you have reusable code, right? It is reusability is the main thing for component-driven. You can, and the maintainability of your application becomes easy. Performance of your application is better, and then it's easier to do testing. And you can also predict as how your application can go. Imagine if you have an e-commerce application like this, right? In that case, when are the times that your application would have most number of visitors. For example, if it's a Thanksgiving sale, right? And then scalability, again, based on how your application becomes larger. So if you have component based on that, if you have a component driven approach, then it's also scalable. So understand that when component driven is something that would help you. And along with that, you can also use design systems, right? There are a lot of people who use Figma, Storybook, Storybook.js. I think I spoke about Storybook.js here in one of the Geekle talks, if you're interested. How to separate, again, it works like, it really worked with my previous company that I was working in, where we had all the stylings. And if you have a lot of application, imagine an application like Google has a application, right? They use their own a design system, Material UI or something like that. If you go to every Google page, for example, you could go to Photos or to Drive. Everything looks seamlessly similar when it's that it's you're navigating inside of Google applications. So those assets can come from, or you can build those things using design systems like Storybook, Chakra UI, or Figma, etc. So this is also this would be coming under those shared folder that I was talking about. So you can build it along with that when you're trying to build a component-driven micro frontend, right? Having said all the beautiful things about micro frontends, now let's talk some of its challenges, right? So every tool, every architecture, every approach has different. It has got its own advantages and disadvantages, but see what works for you, right? So what are some of the challenges, right? It is a complex operation. So complexity will raise due to more people, your code, your resources, etc., right? So you can solve this problem with a solid plan and action, and some practical tactics too, right? And because anybody can deploy it at any time, because it's totally decoupled, it could have an inconsistent user experience. Yeah, that's one of the things, because they're using different set of technologies that I was talking about. You can use Vue, React, or Angular, whatever, right? So that's one of the inconsistent user experience could be one of the challenge. And then communication between components, right? If you're because of the anatomy, autonomy that it focuses, right? Different team autonomy, that could be one of the, if you're not in communication between your teams to build how this component talk to this one, right? Those are some of the things that would. I told you that this is one of the most essential part of a micro frontend. So if you don't have that, then you will have a subpar communication too. And then load capacity. If we talk about load capacity, when teams are separated, tasks, duplication of code can occur, and then if there is a bug, you don't know who is owning what. Which bug? This bug has to go to which team, A or B or C, right? Those some of the things, and then because of that, you get the load or the capacity of people who are working. That's one other thing, and then it'll have an effect of this. And then this is one of the challenges. And again, microservices are not for everybody. Those who can afford it, for example, there is, you have, a single team is responsible for developing, testing various modules. So that's different too, right? So that could be also written in different languages. You take Angular, it will be in TypeScript if they write it in TypeScript. And then you have, JavaScript for React. What happens? There's type issues also come up. So other than that, there's also environmental differences too. So sometimes, the container app, the host app that I was talking about, that can act totally different too. So it becomes very important for the teams to test it, plan it, so to build a very well-structured, efficient, and user-friendly application, you have to have a constant communication. You need to know who owns what, there should be a clear boundaries that you need to set. So that becomes a challenge for micro frontends. Some of the do's and don'ts. So this picture is totally, it speaks for itself. So when you have teams distributed and if they are working, don't make sure that, those teams are all vertical teams and not horizontal. For example, if you have teams like this and then, all the teams build styling, then, that could be avoided. So make sure that as much as possible, you own, you are contained within your area. So that's something that I wanted to mention here. Having talked a lot about micro frontends, is there any out-of-the-box solution, right? There are some frameworks, libraries, or features available. To begin with, is a single page application. You can use a framework, and then you can bring it allows you to build, with multiple frameworks too, right? So it provides you well-defined lifecycle for your micro frontends. That's one thing. And I don't know how to say this, Luigi or Luigi. I've not used this, but this is available. This is also an open source micro frontend framework developed by SAP. So here it allows you to compose complex UI from self-contained independent micro frontends. So there's a built-in support for communication between micro frontends and flexible routing system too. So that's one thing. And then the next framework is called Podium. It uses Node.js, and it enables you to build scalable and modular application by breaking them down into smaller reusable components called pods. That's why it's called as Podium. It handles routing, communication between pods, and server-side rendering, etc. So this is also available that you could tap into it and see if it works for you. And then there's another one called as Open Component. It's also a framework that is developed by OpenTable, and it allows you to share, again, reusable components across different applications. It provides you tool versioning, versioning, dependency management, and server-side rendering too. And there's something called as Bit as well. And there's Webpack module federation library. So this is not a standalone library, but it's rather a feature of Webpack that can be dynamically loaded and shared between applications at runtime. So what it allows you to do is you can build micro frontends that can be developed, deployed, and versioned independently. So that's the beauty if you already have a build tool, if you have Webpack already, right? So that's another thing. Now, which are the companies that uses it, right? So some of the companies that use are, I think this DAZN is a French company. I think it's a commerce company, e-commerce company. And then Upwork, Upwork, we all know. SoundCloud, Spotify, IKEA, HelloFresh, Zalando. These are some of the companies that use micro frontends. And also, I was also reading some articles. Apple could also be a potential one, because you know how they are, teams don't, they're very secretive, right? So they don't want whatever team is working in the other one, they don't want to combine with this. So these are some of the companies that use. And this is a interesting use case that I found online. This is a company that called the Z's, I think, if I pronounce it correctly. What they had is they had a monolith architecture to begin with. As they grew, what happened was they adapted this micro front-end architecture, and they call their micro front-ends as here. There is F1, F2, F3 is there, right? That are for very specific functions. They had AMD library exports, and they called them as Zeslet. And they had a portal host. So the host application, remember the project folder that I showed you? Similar to that, they called that as a portal host, where it exposed all the common APIs and dependencies, and they used micro frontends to architect their front end. So this is one example. Of course, our second example is Netflix. Netflix uses very similar one too. So they use our micro frontends as well. So imagine you are creating, a homepage or a search or user profile, all those things. They architected it as a micro front-end architecture. So we are almost about time. So I just wanted to give you this. I found it in LinkedIn. I thought that this visual is really good. This is how the evolution of architecture happened as a whole, right? So we had this monolith, and then we had front end and back end, and then we had microservices for the back end. And then we also have now micro front ends, where you have all these separate parts of the code, and then you connect it with a base app, and then you also have micro front end and microservices are together here. This is the evolution of together as a whole so far. And some of the, I think, this is how it evolved. And then to summarize everything, here is some of the things that you need to know. So you have when you are moving from the left spectrum to the right, what happens is, as your team grows, the complexity of your code also grows. The decoupling, because of the decoupling, because of all the independent deployments and stuff. So you need there can be duplication of code. Make sure that you're aware of this, right? There's a lot of people involved, and then you might end up in a spaghetti code too, right? So that's some of the things that I wanted to mention. And choose an approach for your application. Not everybody or not every company can use micro frontends, and it could differ for your use case. And mostly micro frontends can be used for medium to large sized applications. So make sure that you collaborate with your teams, right? Communication is the key here to make it work. Like I said, some people disagree with micro frontends. Some people use it, like these large companies, like I mentioned, they all use it. And draw clear edges. When you are working in teams, sometimes you have to make sure that you draw what are the boundaries, who owns what, how do we document it, how are we going to do our deployment, things like that, right? So also start simple, right? You don't have to move everything to a micro front end overnight. Start small and then see if it works for you. If it does not, you can roll it back, right? So that's something, try out. Don't start right away with micro front ends. Probably you can try the modular monolith that I talked about. Then you can move into see if it monorepo works like it works for Airbnb and Google, and see whether it works out. Don't jump into things. Start small, and then see if it works for you, right? And with that said, thank you so much for your time. Once again, my name is Deepa, And also, if you have time, please scan this feedback form. If you have any feedback for me, if you liked it, give me a thumbs up. If you don't like it, please let me know what I could do better. So that way I can add value to this, and we all can learn through this, right? So please give me a feedback. I would appreciate any feedback is good. There's no feedback that's good or bad. Any feedback, any criticism is all good. So once again, thank you so much, Ed, Sia, everybody for having me here. It's a pleasure to be always at Geekle. Thanks a lot, and you have a wonderful day. If you have any questions, I'll try to join the Q&A. If not, please reach out to me on LinkedIn. Thank you.
Thank you, Deepa, for the presentation. It's a great presentation every time. And yeah, let's start the Q&A session. Unfortunately, Deepa cannot join us. So we have Gurmeet with us. Hi.
Hi.
So we received the questions for you. Let's start with the first one. What is the need for a test, like checking the header, which would be visible in the browser? Are there more necessary needs for tests in web apps?
Yeah. Yes. So, like the question is, what is the need for tests like checking? So, I gave the header as an example. Rather, whenever you test the application, for example, so you don't need to write the test for all the code, but many times, for example, our application grows. If we are in a startup, we add more and more components. Then it becomes difficult to check. For example, I have added a feature. Then it becomes difficult to check that is the header is changing, is the sidebar is changing. So if we just write the test, and after creating the feature, just we need to write the line npm run test, so it will be easy to run the test. So that's why I think writing the test will be more reliable way to test whole application if our changes are conflicting with the other changes or not.
Thank you. Thank you for the answer. Next question. When it comes to test, is aiming for 100% coverage the best approach? What other KPIs should we consider to determine if the test in place is sufficient?
Okay, so 100% coverage is not necessary. Like 80 to 90% is reasonable. So like why 100% not good as well? Because that means we are adding the tests which add no value. So for example, if we are making a calculation, for example, we have an array of 1, 2, 3, and we are just multiplying the numbers by 3. So that test is of no use. So that means that's why 80 to 90% coverage is fine. And also the question is what KPIs, like key pointer indicators, I think they mean. Yes. So like test. So firstly, the test should be evolving. Like for example, if today our header has some navigation bar and we add more navigation bar, then test should obviously change. Secondly, the coverage of the file we need to take care of, because if we change our component, then obviously we need to add more tests to cover the file completely. Also I think that is fine. Yes, these are all key pointer indicators.
Great, nice answer. So thank you for the presentation. First of all, thank you for joining us live and answering the questions. It was a pleasure to cooperate with you, and I hope to see you next React Global Summit as well.
Thank you.
Thank you. And yeah, it's time to close the junior track of React Global Summit 24. I would like to extend a big thank you to all the speakers who presented today. It was incredible opportunity to collaborate with all of you. Also, I would like to say thank you to our dedicated program committee member, Roberto Bianchi, who helped us to put the program together to sort topics for junior, for senior track. His help is much appreciated, and he's also presenting tomorrow. So I'm encouraging you to grab yourself a ticket with the promo code React Live. Those who join us tomorrow will have access to more complex, more deep dive topics. We will have 9 presentations from wonderful speakers, and also those who have this ticket will access individual recordings of the speakers after the conference, and also they will receive a certificate by mail after the end of the live stream. So thank you so much for your participation, for being active in the chat, and see you tomorrow.